now. Sorry. Last stream I completely forgot. So let me just make sure. We're gonna have to do what I just did again, but okay. Hopefully the two of you come back. We're on a different stream now, but you know. Okay, welcome back. Let's make sure it actually looks good. Yeah, see, that looks so much better than before. Oh my god, it's actually like clear now. All right, cool. And then once again, we'll make sure Twitch isn't crapping itself. I think Twitch forces it to be like 720p or something. I'm not really sure. Yeah. Oh, okay, you can watch it at source. Oh, wow. You've got some variable. You got some variable stuff going on. That's not bad. Cool. All right, well, I'm gonna close this before the universe explodes. Hey, Frank, what's up? Sorry, I can't see chat right now. Hold on. Okay, I had to restart it. I can now see chat. I can now see chat. So, what are we doing today specifically? Well, for that to make sense, this is very bright, by the way. What did we do last stream? So last stream, we finished this, but more specifically this. We finished the circuit board. No idea if it works, probably doesn't, but that's what we're doing today. We're gonna figure out if it works. So we're gonna test all of these connections, using this, and just make sure it actually works. And we're gonna do that by breadboarding it. So we've got like this thing, and I can hook wires into it, right? And it makes the connections without soldering. So that's what we're gonna do today. I almost forgot. Let's just make sure. Yeah, that's the correct link. That board is clean. I know. You should see this one. It's kind of gross, but this one's nice. This one came with my kit that I bought a couple months ago, 8 months ago, and I never used it. Or I did use it, but I didn't destroy it. So the Discord, I need to go here, and then nope, go here. Forgot to notify everyone. All right. I need to share it after I update the thumbnail. This used to be my thumbnail. Oh boy. And then if you guys need to show me something, I realize now my camera's large. If you guys need to show me something, go in the stream chat channel. All right. But anyway, I think we're good to go. Oh, is the Lo-Fi too loud? All right. It's good for me, but I think it is going to be louder for you guys. Let me hear what you guys hear. It's not that loud, but we can tone it down. Is that better? Is that better, Mr. Duck? You only have tiny boards? Oh, nice, yeah. Yeah, the big one it's nice. Hey, Bondrew. Can you... Mr. Bondrew, can you make your name on YouTube the same as everywhere else? Yeah, I just did. I just pinged him. Because it's just confusing to me. All right, guys. So what are we doing? I'm thinking we start with the NRF chip, just to make sure that works, and then just ignore it for the rest of the night. So that's what I'm thinking. Let me show you what we got here. I got a different tripod for my camera that's farther away. So I would show you with the other camera, but I don't want to move it. So here's our little setup, okay? I showed this off in the Discord, but it's kind of like a mock-up. Well, I basically 3D printed the PCB and just shoved everything into it. Obviously, there will be more stuff on the back, but that's kind of not possible at the moment. But yeah, so like everything fits. The holes are the right sizes. But we're gonna test this. If I can get it out. Ow. There we go. I could have made it looser, but I didn't want things falling out. So we're gonna test this, the NRF chip. Let's just shove that in there. We'll need the nano, which is going to be very difficult to remove. And then we'll need these two capacitors. And the voltage regulator. I'm gonna get the nano out really quick. Okay. There we go. So, let's put this to the side. What are we doing here? I can actually just use this thing to see exactly how to hook everything up. And we're just gonna go one by one. So, unfortunately, I can't shove this into the breadboard because, well, if you don't know how breadboards work, basically, okay, so in the orientation I'm holding it, we've got rows and we've got columns, all right? These outer two rows and these outer two rows, we're just gonna ignore for now. So rows are not connected at all, okay? Not even a little bit. Columns are. So, for example, I just need something to point with. Okay, I don't know what happened with this one, but we're just gonna. Okay. So, for example, these 5, 6, 5, these 5 are all internally. Crap! Could you guys not see that? These 5 are all internally connected. So, for example, if I do that, those are connected, okay? Those are connected. If I do that, even though they're on the same column, column 32, they're not connected. So I lied, I'm sorry. This center thing breaks up the columns. So they're connected this way, they're connected this way, not connected in the rows. And then these two rows and these two rows, so these four outer rows, they are connected, but they're not connected in the columns. So you can use that for like power. But that's how that works. And so why can't I just hook the NRF into it? Well, no matter which way I hook it, we're going to be shorting some, like they're going to be connected in a bad way. So we're going to have to just wire this up individually. But yeah, so let's start. Let's do that. I don't want to use this one because it's kind of gross. So we're only going to use that one if we need to. So let's start with this. I'm just going to put this, I mean, I can put it in the middle. I'm just going to put it all the way at the top. That might, no, that's, I'm going to put it here. Now, is this going to go in nicely? You know, the breadboards that aren't worn in are harder to use. Let's try this one. Oh my goodness. Ugh. Yeah, you see how it's like poking out the back? Okay, I'm not sure if I trust this one. I'm gonna be honest. I'm not liking that one. All right, I'm gonna try my best to shove this in without breaking anything. There we go. Yeah, the tracks on the back are poking out a little, so I'm just gonna push those back in. All right. Okay. We got it. The reason I hook it over this is so the pins on either side aren't connected. So what's next? We're just gonna go one by one. You'll stay on Twitch? Yeah. That's fair. You can't figure out how to change your name on YouTube, guys. Other way around so you can easily access the... Yeah, okay. You're literally working on your Raspberry Pi? Nice, that's awesome. All right, so what are we gonna start with? Let's start with ground and power. So, of the Nano, because well, actually the Nano is not gonna need power, because it's gonna, for these tests, it's going to use the USB, and yeah, oh, no, that's not true. That's not true. No, so, oh, I guess I should hook up the battery as well. Okay. Let me think. So we've got the Nano, let's do the battery. So I hooked a bunch of pins to this charger chip. So I can actually like interface with it easily. So the only thing we really care about with this, well, two things, I guess. The battery in, the battery out. Here's our battery, and we're just gonna connect these. So we've got these, this is female to male. I need a female to female wire if possible. I think I have some, but I'm not entirely sure. I guess I don't need that. You know what I can do is this. I'm gonna hook the battery into the ground of this and the plus of this. Yeah, that makes the most sense. All right, so this this entire bottom track is powered. I don't want to lose these. Great, now what? Okay, I'm realizing I don't actually need this charger chip at all. Although, no, that's not true. I do need it. I'm sorry. I do need it because this brings it to 5 volts. So, okay. We want, yeah, male to female. So we're gonna do battery plus to battery plus. Like that. And then we need one more. Right here. minus. It's better than minus. All right. And let's just quickly check, a little sanity check, if it's actually, it's upside down for you guys, I'm aware, but sorry. This is not an ideal working spot. I don't really need my keyboard when I'm streaming, do I? Well, I guess when I'm doing this, I guess it depends. All right, anyway. We're looking for like 5 volts out of this. Let's check the track first. It's kind of hard. Yeah, okay, so we've got 4 volts from the battery. I'll show it to you guys because I'm nice. There you go. This is harder than it looks. Okay. So that's the battery track, power track, whatever. Let's check the charger. So I'm gonna do. This is V out plus. Oh my goodness. And V out minus, and it should be. Okay, that's not good. It's 5.4 volts. We want that to be 5 volts. So what we're gonna do, so, it looks like the little adjuster thing got twisted. That's the only explanation. So I'm gonna try to twist it back. That should have been 5 volts exactly. But I've been messing with this and I must have accidentally bumped it. Okay, so notice how it's different. That's good. So what I need to do is somehow measure this while still being able to change it. Okay, let's see here. I don't think that's working. What I really need is like little clips. Why is that slowly going down? What is happening? What on earth? This is weird. Okay, that's better. It's because I was like touching it and being. It's just because the contact wasn't good. All right, that's good, I guess. All right, I need some sort of like alligator clips or something, but I don't think I have those. Actually, I might. Hold on, I might have those. So I have an oscilloscope with like 1 alligator clip, but how can I do this? There should be a better way. Maybe, yeah, I probably was. Maybe add a zener or something? I have no idea what that is. So you're limited to 5 volts on your PCB. I don't know what a zero. I mean, the charger thing should work. So we should try to get that working first. All right, let's wire. Actually, I'm gonna just keep my headphones off. Oh my gosh. All right, let's wire this up to the PCB. Jesus Christ. So let's see. This is plus. It'll be easier to measure like this. we're just gonna put it right here. And we need one more. This will be minus. It's nice to color code it, but well, it is nice to color code it. No buts. It's fine though for now. We're in a slight crisis at the moment. Okay, and I'm gonna pull them out just a little bit so I can easily get to them. And so minus is on the right. Now this should be a steady 5.4. Okay. Okay, now I need to do this with one hand and then twist. Damn it. This is hard to do. This is why you need a multimeter with clips. Okay. Now with this hand, I'm gonna just twist it. I can't get the leverage. That little thing right there, I need to twist. But it's really hard to do with just my right hand. Oh my god, how did I do this? How did I do it before? Okay, you know what? This is what we're gonna do. This is the only thing I can think of. Oh wait. I have tape. Hold on. I just recently got a new soldering thing, and it came with alligator clips. So this we're being resourceful here. Man, I didn't think I'd have to do this, but because I thought my battery was already like figured out. I wonder if I could like. No, that's not. All right, and I just need to clip one of them because I can hold the other. Oh my god, this is like unbelievable. Here we go. Okay, I think we can. Don't touch that. Okay, good. Now what? I still... This is insane. Alright, we're doing the other one. This clip is connected to a big thing, but it's fine. Yeah, you know, after this, I'm gonna buy a multimeter with alligator clips. Alright. Holy moly. Watch it like not work. Okay, that's the wrong way. Oh my god, we're so close. I've got it to 5.1 before. Okay, that's probably fine, but it's annoying. Oh, I mean, okay. We're happy with that. Whew, all right. We've got 5 volts. That was... Holy shit. That was annoying. All right. We've got 5 volts. We are happy. Now, do not touch that little circle thing. So, what are we doing with these 5 volts? Well, the first thing is putting the plus, which is black for some reason. Do I have a red one? I think this is green. I can't tell though. I want a red wire. Oh, I found a red wire, but it's messed up. I have so many. Oh, these are two-way. We've got a red wire instead of black. Just so we can visually see without having to double check. Yep, that's VL plus. plus, this is VL minus. All right, we can finally make our first connection. Holy crap. Which is the power to the Arduino. We're just gonna shove everything over there. All right, power to the Arduino. Let's see. All right, that's 5 volts in, which, because, I mean, it's 5 volts. And then ground. Now, when we connect the ground, it might power on, but I'm not sure. Yeah, it did. So that's good, right? One last check to make sure we're not breaking it. Can you guys see this? Yeah. Just really quick. Just can I do a really quick check? I just want to make sure it's still good. Hey, all right. 4.99, that's interesting, but I'm sure it's fine. All right. It's gonna be not great if the voltage lowers as more amps are pulled, but we'll see. We might have to go with VN. Although VN's supposed to be 6 volts, so why you doesn't try something like Fisky or like the controller of Zenta? I'm making a controller right now. It's gonna look really nice, hopefully. So I'm gonna unplug the battery's power because I don't want to drain it. And well, what's next? So we've got the nano power. That's really all I'm concerned with the nano. It's got the 5 volts in and it's got ground. So what are we gonna do with the NRF? Well, I mean, I think I'm gonna need more. I'm gonna need more of these wires. Like specifically the female to male jumpers. I'm gonna need like a bunch of those. I do have a bunch right here. I mean, this is good for now, but I'm just gonna bring them all over. All right, this is like, oh god, the majority. Oh, this isn't. Ugh. All right. This is good for now, I think. I don't know what this is doing here. Okay. Let's get this out of the way. Okay. So the NRF is right here. Nice. So you can see what the pins are on the back. Hopefully you can see that. Is it ever gonna focus? Yeah, there you go. I'm gonna do it this way. I know it's upside down for you. So let's ignore V plus for now and ignore ground. No, we don't have to ignore. Let's do ground first. So found a black wire, not the right type. Doesn't have to be black. Not a huge deal. I'm gonna put all of the male to male wires. I have literally no use for them right now. I'm gonna put them right there. There's a good amount in this pile, which is annoying. All right. Anyway, let's do this. So ground is this, and we're just gonna hook it to our ground. That's simple. All right. CSN. We want that on D5, although I'm not sure if I updated this, so let's just see what's over here. Okay, we did. So D5. So we want CSN, which is this pin, on the Arduino's D5, which is right here. to be D6. All right. Where did I put these? Oh, right here. SCK is D13. So SCK. D13 is way over here. All right. MOSI is D11, and then MISO is D12. So let's do MISO first. Which is that one. D12. All right, and then last one aside from power is MOSI, which is D11. All right. IRQ is not connected to anything. All right, finally, we want power. So this is where it gets a little bit interesting. So with power, well, you can see it doesn't just go directly into the Arduino's power. We're using this voltage regulator. So let's try to figure out how to use that. I don't know which side. I'm gonna have to look this up because I don't know on this voltage regulator which side is which. Like which is V in and which is V out, or maybe it doesn't. I have a feeling it does matter. So this is it's a voltage regulator. While I'm not using my camera, I'm gonna turn it off. I really don't want this to overheat. It's already getting hot. It's not that hot, but I don't need this anymore. Just put it over here. All right, voltage regulator. It's like H333 or something. Oh, 7. Oh, here it is. Nope, that's definitely not it. Unless it is. No, it's close. Through hole technology? No. All right, I'm gonna find it. I'm gonna find the exact one I bought on Amazon because clearly I don't know how to look things up. Here it is. So it is the HT73. Okay. I guess pinout? I don't know. Yeah, which is in and which is out? I have no idea. Oh, here we go. Okay. Finally. All right. That ground is on the left? All right. So this is saying ground of, let me go back to this. Yeah, it's the HT292. What does that mean? So I don't know if you can see this. Well, I actually do know because I'm looking. That's the flat side, right? So the flat side. So apparently this on the far left is ground, far right is V out, middle is V in. I guess I could have gone to the KiCad thing and see how I did it. See, this is actually different. So this is saying ground's in the middle. So which one is it? Are you serious? Like, Okay, now I'm second guessing everything. Let's see what. Okay, this also. No, ground's on the left. Oh wait, JP1. I don't know what that means. I don't know. What is happening? I mean, it's important that we figure this out. TO92 is the package. All right, let's try searching that. I mean, is that the one I have? 7333 minus A. I feel like it'd be nice if it told me, but yeah, that. Yes. No, but mine is QN224, but I don't know if that matters. Is it gonna tell me which side's grounds? No, why would it do that? Okay. Did you find it? Scroll a bit. Did I find it? At least you found it, thank you. I'm looking for the through hole one. Here we go. What is it? I just want to look at it. Like, okay, yes. So ground is on the outside, and I literally hooked it up wrong. But like, I don't know if you guys, it's hard to see. This is unbelievable. Which, is this the flat side or is this the curved side? This is unbelievable. Okay, I guess this would be the flat side because that's where the text is. So yeah, ground, okay, so ground's on the left, VN's in the middle. Yeah, you're looking at the flat side. Okay. Okay, so why is this wrong? Why was this wrong? Did I get the wrong footprint? What is happening? What the hell happened here? How did I mess that up? What is this? TOSOT. What on earth? What is this footprint? What did I do? Like, I know I can change it, but like, I don't even know what to search here. It's a voltage regulator. Whatever. I really. It fit when in the 3D printed test. I guess I just edit the footprint. I don't know what else to do. How do I make, wait, this is showing that the left is ground. Oh, did I mess it up? Oh, I think this was my fault. Okay. So this should be ground, but I mean, it's clearly not. I think it's because I messed it up in here. Okay, but what is this? Like, where did I make this? Oh no, did I make this? No, I didn't freaking make this. What is this? This isn't the through hole one, is it? Cause like, Let me think. So what should be pin? So, frick. Pin 2 is in, pin 3 is out, pin 1 is ground. Can we handle that? Pin 1 is ground, pin 2 is in, pin 3 is out. Let me just confirm. 3 is out, yes, okay. So now if we update this, okay, and now the wires are wrong, but at least like, I am going to scream. Dude, I hate this program sometimes. What? Oh, now it works. It's literally not letting me. Oh, because it's not supposed to be there. Okay, maybe that's why. Okay. All right. This is unbelievable. Okay, there we go. There we go. Everything's fine. Everything is fine. All right. Wow, that was fun. All right. So, left is ground. Middle is in. Right is out. Wonderful. I don't know why I minimized that. That was easy to figure out. V to change to the back side. Oh, I didn't know that. This is drastically increasing your appreciation. Great, I'm glad to hear that. The one on the silk screen looks incorrect. You would be correct. Wait, when you say silk screen, what's wrong with? No, this is definitely right because it's revert. Oh, frick. No, this is right. This is right because it's reversed. Yes. Everything's right now. It's so fun. Okay. Can you guys can see this? Yeah. I'm gonna do it in relation to my orientation. So we've got left is ground. Now part of me just wants to shove it in the ground, but that's not good. So we are going to get our first small wire. Okay. I don't care how much space this takes up, by the way, because this NRF circuit I am not keeping. I'm just making sure that this works. I'm pretty sure it will, but that's why we're doing this. All right. Do I snip the middle of this? Let's see. Oh wow. Okay. She goes deep. All right. So left is ground. So far so good. V in. So what do we want going into this? Well, let's see. 5 volts. Okay. Do we want the Arduino's 5 volts or the battery's 5 volts? It's looking like the Arduino's, but where's the charger? Here it is. Well, I guess it doesn't matter, does it? Why would it matter? It's the same thing. Okay. So, well, we need another small wire. Probably should have attached that beforehand. Let's just do this. And don't worry, the power is not hooked up right now. I made sure to unplug that. probably fine. And then V out. So this is the final wire. It's the final wire to the NRF chip. The V out. So let's look that up. Wow. Wonderful. Okay. Okay. We're missing something. We're missing the capacitors. Now, the capacitors, as far as I understand, make the signal more stable or something. If you couldn't tell, of all the things that this Hexapod project, all the skills rather, this Hexapod project requires, the electrical side is my weakest by far. But, I mean, I got this far. Anyway, capacitor. So, we've got a plus and a minus side somewhere. For some reason, it's not saying which side. Does anyone know if the black side is plus or is the white side plus? Because there's no symbol on this that I can see. I just want it to already be plugged in. I hate this so much. Okay, it looks like the white. This one has a minus symbol, okay? The other one doesn't, so that's fun. Yeah, capacitors are scary. White is negative. Okay, so we have a confirmation. So the idea is we want a capacitor in between the power and the ground of the NRF as close as possible. We also want a capacitor between the ground and the V out of the voltage regulator, again, as close as possible to that. So let's, well, okay, we're only gonna do one for this, and the reason is that I can't really hook up a capacitor like here without a significant amount of effort. So we're not going to do that. But what we are gonna do is hook up on the voltage regulator side. Frankly, I don't think we need it either side, but I don't know anything, so I'm just gonna trust what the online tutorial said. V out and ground. So the ground is minus, the V out is plus. So the short one is minus, the long one is plus. I forgot what ground was. Ground is this one, and the V out, which is the outside one. All right, so we want to put this right here. Oh, baby, look at that. Okay, now we're actually done. So this is the NRF circuit. I'm not gonna plug in the battery yet. What I'm gonna do is actually go into the code. And just review it. So all this code, I feel like it'll be fine because these pins are all being hooked up in the code, but on the Nano, they're just not hooked up, which is fine. What we care about in the code is, well, I'll go through it soon, but is this function. That's not true. Hold on. I swear to God, I had a function that like defaulted the values. Wait, I actually might not. Wait, hold on. Huh. Interesting. Well, there's only one way to find out. I mean, I guess they're all just gonna be 0. Cause like, there's nothing to read. So we'll find out. Look, I just want to see if it connects. That's all I'm concerned about. I'm a little scared, but you know what? Here we go. So we're gonna upload the code, turn the hexapod on, and see. So what I do know, what is important, okay. What's important is that when the hexapod is on and the controller is off, it does something. And then when the controller's on, it does something else. So we'll know if it actually connects. You can't see this. I want you guys to see this. Cool. All right. USB-C. I bought some USB-C nanos because I hate micro USB. Before the stream, I already made sure that. Well, okay. I can change back, I guess, because no one cares. The PC or the breadboard's not going to change, probably. I made sure before the stream that this actually worked, and it does. Now, I didn't try uploading the code, though, so it might blow up. I don't even know where the upload button is. Oh, I think it's right here. It's been a while. So we're going to upload. Great. Okay. Okay, this is a new PC. I don't have the directory for the NRF library. In fact, I don't have any of this. Okay. Can we install it? Maybe I should have tested this before the stream. How do I install libraries? It has been a very long time. NRF 24. I have not touched this code in a while. Okay, this is concerning. Is it this one? I mean, oh, this is this. Am I even using this? Wait. Okay, well, RF24, RF24. I mean, there's no way that's not correct, right? Okay. What the frick is... What is this? This is concerning. Do I have to, like, get this from online or something? I'm considering just deleting this. Because, like, I don't see... I mean, that's where it... Oh. Oh, RF24. Oh, this is the RF24. Then why do I have this? Wait, that doesn't... Okay, I'm going to delete... That doesn't make any sense. I mean, I guess I'll comment it out. Just in case. But, like, the NRF24 thing is a part of this. So, I don't know what's going on there. Yay. Okay, that's good. That's good. Okay, so we're gonna unplug this. That's fine. That's, maybe we shouldn't have unplugged. Failed uploading, what are you talking about? It was already uploaded, wasn't it? Oh my god, I swear to god if I just broke my Nano. I mean, I have other ones, but... Was it not uploaded? Did I pull it out while it was uploading? Oh my god, I actually did. Okay, wow, I'm an idiot. But still, why is it taking so long? It's never taken this long. Yeah, I actually did pull it out while it was uploading. What's going on here? This is really weird. Yeah, no smoke came out. That's good. This is... I've never seen this before. It's not... Okay. So like it's actively uploading right now, apparently. I probably like missed a setting or something. I don't know. Oh, okay, we got something. Programmer is not responding. Okay, I probably need to do something. Well, at least we got an error. Oh, okay. We're gonna get a nicer USB-C cable and hopefully that works. Oh, didn't it come? Wait, hold on. I think it came with a cable. Although I have no idea where that went. In fact, it definitely came with a cable. But I definitely misplaced it. Shit. I have so many wires. I hate this. Where did I put that cable? That's not it. I have so many. No. I know it's not this. Where are my USB-C cables? Holy crap. Oh, here. Alright, let's try this one. It's a really short one. The one I used is definitely not the original. That's probably... whatever. Here we go. Let's try the same USB port and a different cable. See what happens. It's not going. Ugh. Should not be that tight, but okay. Upload. Oh, well, at least that makes sense. So the COM thing is because well, actually, I don't know. Oh my god. This USB is like hardcore. Is this USB-C? Is this wire even worse? Like, I didn't change the code. I can't. I'll save it. I'm gonna try reloading it and then, well, we'll figure something out. That's what I get for USB-C, no kidding. Look, worst case, guys, if I can't figure this out, I have a Nano that I know for a fact works, but I want to try to get the new one to work, so. Rotate the USB-C. Okay, I just don't understand why, like, why did this wire work? Well, almost. Why did that work? Why does this work, but then I can't upload anything? Frick. All right, let's try a different one, I guess. There we go. This one's gotta work. Can I just cancel this? Like, I know it's not gonna work. But I feel like if I stop it now, it's gonna, like, freak out. I don't care. I genuinely don't care. Okay. I low-key kind of hope it breaks the nano, to be honest. Alright, so those two didn't work. Let's try this one. The wires are getting short. They're getting shorter and shorter. I mean, I don't understand. Oh my god. Oh, maybe I should have like actually read this. Hold on. Oh, this had 0 upvote. I was reading the 0 upvote comment. All right. Well, I mean, there's only 1 upvote total, but still. Oh, maybe I don't have the right driver. I mean, I definitely don't have the right drivers. Okay, so are there... Seems like there are drivers I need. Interesting. Maybe. I don't know, but I just put the code in... Dude, I don't know what you're saying. I'm sorry. The USB 2.0 lanes and USB-Cs are KiCad. Yeah. Oh, you're not joking? I can try. I can try rotating it, but man, if this works, I don't even know what the original way was. How does that happen? How do all my wires, like, freaking fall off? Oh my goodness. All right. Just made a footprint. Okay. Why are you showing me this now? All right. I mean, clearly it sees it, right? This is clearly working. But it's like uploading and then just gives up. Okay. We're gonna rotate it. We have rotated the USB-C. If this works, I am going to be annoyed. So, assuming this doesn't work, what's our next plan? Test other ports. No, this is taking too long. This is not working. All right, let's try a different USB port because why not? This is like a nice USB though. Maybe it's not. COM4. There you go. It is a nano. What is all this shit? I mean, I'm just okay. Do I have to click one of? I don't know. Okay, now we're on COM4. Here we go. Wow. I would have never guessed. All right. Let's try that. Tools. Processor. Old bootloader. We're gonna cancel the uploading before I change any of that shit. Okay, tools, processor, old bootloader. Oh, we're indexing. I don't know what that means, but let's try it again. Okay, maybe I have to restart. I mean, it's... Okay, now we're going to go on to the Amazon page and see what the comments say. This is what I would do. I'm not, look, I have a working Nano and I will use it for the sake of this stream, but I will try as hard as possible first to get this working. So, older version of the IDE, I have not tried that. Oh God, what if my working Nano doesn't work? That would not be good. So it came with a cable, which I lost, but I can find it maybe. Let's just see what the comments say. The comments said that these all worked without. Oh, okay. Had to update my IDE to include the Nano board. To update the IDE, I did the following steps. Now, this comment was September 12th. That's pretty recent. Interesting. All right, it's updated. Okay, I'm thinking it's my cord. I don't know what else it would be. So I need to. I am on a mission to find the original cord that came with this. I know it's somewhere. It has to be. I would not throw something like this out. I'm checking behind my monitor right now. It's somewhere. I know it's somewhere. The question is where? Where is it? Okay, I don't see it down there. Where did I put it? I would have put it in my cord drawer. Right? What the hell is this? Alright. This has to be it. No, this is a Sony one. Okay, well, let's try it. Oh, they're getting shorter and shorter. This is insane. I kind of hope this doesn't work at this point, because like, it's so short. Great. Make sure the connections don't fall out. I really hope this doesn't work. Well, it's going to work because I hoped it doesn't work. That's what's gonna happen. Please don't work. Oh no. Oh no, it actually, okay. Okay, good. Okay. Same issue. Guys, I'm thinking even if I find the original, it would have this issue. It's stuck at uploading. We can figure this out. We're so close. It's stuck at uploading. I love how I'm just exiting it while it's uploading. Okay, I've gone back to the new bootloader. think I have to like... Okay. That's new. I don't know if it's good or not. Was that my... Did I do something here? I don't know if this is good or not, but we're... What do you mean make sure the correct... There's only one port! Did I open Arduino twice? What's... Oh my god, it's because I closed it while it was uploading. That had to be it. Hold on. I'm almost positive that's it. That had to be it. Okay, note to self, don't do that. Oh my god, there's so much here. Okay, I don't... Shit. We're just gonna... Yeah. Okay. Let's try this again. Can you read the info from the Nano? What do you mean? Oh my god, you want to offer me a promotion? I'm gonna pass. I actually don't care how many viewers I have. I genuinely don't. So, and I know you're a bot, but I'm, yeah, okay. Here we go. Nice. All right, well, one step backward, one step forward. That's not the issue I have. What's up? Get board info? Sure. There you go. Unknown. That's not good. Is this the driver for the Nano? Or is this a driver for Windows? No, this is the Nano driver. As far as I understand, the Nano has the software in it. Well, look, we're gonna go back to the long charging cable, or the long cable, because that got the same results, and it's longer. So from here, hopefully, we can figure it out. All right. What do you mean try with the driver? Like, do I need to install? I had the same issue. I installed an older version of Arduino and fixed the issue. Okay, hey, I'm open to anything. Oh, yeah, no. At this point, and I probably had an old IDE on my previous computer. You know what, just really quick. Speedy quick. I'm looking for the Nano, the old Nano. just did this. I unplugged like my old project that had the nano. Whatever. I mean, I have this. I need a bigger desk. All right. I mean, if I plug this into the controller and it wipes the code from my controller, I'm gonna be unhappy. I'm gonna be very unhappy. That would not be a good thing. I don't understand where my old nano went. I have my other new nanos, but my old one is like gone. I'm gonna check. Oh, it might be. I have yet to label my I know where it's not, which doesn't really help. I think I left it on the floor. It's just gone. Okay, well, I think the cat's got to it. We are going to try the Uno. Now, can I find the cord for the Uno? Yes. Yes. No. Please. Thank God. All right. Okay. Okay. I've got the Uno cord. I've got the Uno. We're just gonna see if I can upload the code to it before doing anything else. I know. Oh, did you say which Arduino IDE version you had? 1.8. 1.8. Okay. All right. So we've got COM5 is the Uno. It knows it's the Uno. We're just gonna upload the code. And I'm kind of hoping this doesn't work. Shit. Okay, well. Huh. It seems like the problem is the nano. Because that worked. Or the cord. Could be the cord. I feel like it's not the cord though, since it like recognized the COM port. But maybe it is the cord. God, if it's the cord, I'm gonna be annoyed. At least something worked though. That is technically progress. Hey, oh, hey Steph, what's up? Oh, that is technically progress. Let's look for the cord some more, I guess. Alright, it's not this one. It's definitely not this one. Here's another Sony cord. It's not this one. USB-C to USB-C. All right, we got 2 more tries, and then we're gonna have to do something else. We'll do this one last. We've got another Sony USB-C, which I don't have high hopes for. But here goes nothing. So if these two don't work, we can try the older IDE. COM4, that is correct. And we are on the normal bootloader, by the way. Okay, that is clearly not working. I'll give it like 5 more seconds. You have a different nano? I have 3 new nanos, and I cannot find for the life of me any of the other ones, except the one that's already in my controller, which I'm not touching, because if I'm not able to update that, or if I like wipe the code without being able to update it, that's not good. All right, that did not work. Last try. I don't have any other chords. I mean, I have some other chords. Guess I could try them, but this should be COM6, possibly. I feel like we should have tried this first. COM6, good. Nano, okay. Here goes nothing. I was hoping that one would work. All right, it has to be something to do with this nano, right? Like, it's gotta be. Yeah, that didn't work. Let's try this one. I mean, at some point, okay, it's gotta be the nano, right? Like, it's gotta be. There's no way all of these chords are messed up. There's no way. There's no way. I have 2 other nanos. Maybe it's the nano. We can try. But I have a feeling it's gonna have the same fate. Okay, this is flashing blue. That's interesting. What the fuck? It worked. Was it actually the nano? Wait, what? Why did that work? What's wrong with my nano? Why did this one work? What is happening? Okay, alright. I mean, maybe they tried. I don't remember which one. I have 2 in front of me. I don't remember which one I tested, so I'm just going to do this one. It's flashing blue. I don't think mine did that. The battery's not connected, by the way, just to be clear. Although it is connected to... It's not connected to anything. It's flashing blue. You can kind of see it. I mean, I'll show you guys. I don't know what that means. Okay. There's the power is green, and then the next one is L, and that's flashing blue. Did I like... RX and TX pins are fine. All right, and then again, let's try this one, which is not flashing blue, but is blue. Yeah, okay, that worked. Okay, so these two work with this cord, which is long, so that's good. I have a feeling it would have worked for any of the other cords too, but last test. I'm gonna pull the Arduino Nano out of the circuitry and I'm gonna try. Oh my god. I mean, I have to anyway, right? What the what happened? How do I get... Alright. I mean, there's no way that this works. No, it's not flashing blue. The blue LED isn't on. I think I just got really, really unlucky. Because the reviews on this were, like, fantastic. Wow, I just got really unlucky. Huh. I mean, I'm not gonna pretend like I know what's wrong with this. I'm pressing the reset button, or at least I think that's the reset button. There's a little button in the middle, yeah. I don't know what that's doing. You know what? I did power this on originally without... Wait. I don't know if that'll do anything, but... Okay, let's give it one more chance before completely giving up on it. I'm gonna plug the battery in and then see what happens from there. Okay, so it's on. Maybe I plug the battery in and plug it in at the same time. I don't know. I don't know what the frick's wrong with this. I don't know if that's gonna help or hurt. I really have no idea. I can't imagine it would help. Okay, I don't know. I tried, dude. I tried. I mean, I'll press it more while it's uploading. You want me to hold it? I'll hold it. I'll hold it. I'm still holding it. You got a batch of 4? Wow. All right. Well, fair enough. I give up. At least we got 2 that works. Better, better than yours. Jesus. When in doubt, try the other Arduinos, I guess. Yeah, I mean, one bad connection and it'll ruin the whole thing, I guess. All right. One bad connection, like in the PCB. Still annoyed I couldn't find... I'll clean that up later. I couldn't find the USB micro USB, no, but whatever. Watch it not work once I hook up everything. So, here we go. Nano number 2. It's very possible that when I was trying to shove the first one in, I broke it, but I'd rather just blame them, to be honest. All right, here we go. I mean, it already has the code updated. The thing, like, this has a blue light, and the other ones did, or the other one didn't. The 2 working ones have a blue light. So, yeah, it worked. I know you can't see it, but it worked. So cool. Be glad you're not uploading to an A1085 with I don't even know what that means. Yeah, no, going to the old version's what I would have done if this didn't work. So, but anyway, okay, we can finally continue. Here we go, guys. So I'm gonna go to this scene, I think. Yeah, this is good. And I'll make this a little bit bigger. So the camera's off. I was like, why isn't it updating? Here we go. When this powers on, when this thing powers on, it should make the hexapod do something. Because, yeah, the code has not changed. What the hexapod's doing right now is what happens when the controller is not connected. It puts all its legs up. It's a calibration mode. I'm gonna connect it. Here we go. And it should, well, it might like start freaking out and fall off the table. So and of course, a servo died or something. I don't even know. I think everything is just going wrong, but that's fine. So I don't need that servo to be working to test this. So here we go. When I connect this, it should immediately connect with the hexapod. Okay, I don't think it did. So that's depressing, but why? I don't know. I'm just making sure nothing unplugged itself before. Should we try a different NRF? That's voltage. All right, let's start seeing like with the multimeter what's going on here. Because we're using a voltage regulator this time, so you think it would actually work better than not using one. Alright, let's see. So I'll make this right side up for you guys. Let's try. I mean, first off, let's just try the power. So this should be like 3.7 volts. Or 4 volts, that's fine. Okay, let's see what the voltage regulator looks like. That's what I'm most curious about, to be honest. This should be 3.3, yeah. Does that say negative 3.3? Oh, did I do it wrong? Oh, yep, because that appears to be a pretty good voltage. So it's not the power. Could it be that I connected to the ground? That I connected the ground to? Well, like what if we connected it to this ground instead? No. And just to like, I'm just gonna turn this on. That's what should happen, okay? When it senses like a connection. Could be the code. I don't think it's the code though. It could be the code actually. It like never gets to this point. That's very possible. It could be the code. Let's just make sure everything's wired. I mean, everything looks to be wired properly. Oh my God, the pins. Oh my God. I wonder if anyone caught that. It most likely has the wrong pins. Like up here, 9 and 10. I don't think they're 9 and 10. So, well, what are they? I wonder if anyone caught that. Oh, the music's loud? I can turn it down. You are not the first person to say that. Hopefully that's better. I can't hear it at all, so. Do you have the STL of the stand? Yeah, it's in the GitHub. It's in the GitHub link. Can the Nano work on 4 volts? I think it needs 5 or more. Does the other antenna even connect with the hex? Yes. Wouldn't it be running on a different band? No. It's all this is what it's searching for. You can't even see my screen right now, but wow, you can. Okay. It's searching for the. I don't know what you mean by band, to be honest, but the NRF is searching for this on the other NRF, and it's the same, but the pin was wrong. So CSN is 5, CE is 6. So CSN is 5. We're gonna comment this out actually, because this is correct for the original controller, but for the new controller, I said CSN is 5, CE is 6. And let's try it now. Yep, I did get 3. I was getting 3.3. Check the board's menu. Oh, sure. I didn't do that before. Is this what you mean? Oh, we still get that. Interesting. Okay. Now, the fact that it didn't immediately start is kind of... I'm not sure if this is going to work either. Just making sure D5. Is CSN. Yep, that's what I have. Okay. I mean, let's try the battery, although I don't think this will work either. Yeah. Huh. All right. Well, that's one issue fixed. I mean, clearly nothing happens, but that's what should happen. You have the right nano selected in the boards menu. I mean, I think so. What do you mean? I mean, look, dude, the code is uploading. I measured in the low 4 volt range. Okay, I mean, I can... I thought I already checked that. Here. Oh, I double pressed it. Seriously, is the transition up? Okay. Did I actually just bug out? Oh my god. Okay, OBS is currently bugged out and I cannot change to my other scene because oh my goodness. Okay, at least there. There we go. Okay. Holy shit. Everything that's going wrong that can go wrong is. Alright, I mean, I'll show you again. So the battery is currently, I'm not getting, it's, the battery's fine, I promise. It's just because the contact points I'm using. It's enough, but what is the nano getting is the question. Well, it's getting less now. Man, maybe this charger thing isn't great. All right, we're gonna try something. I'm gonna use the V in. That's a good call. That might be the issue. Instead of the 5 volts, I'm gonna use the V in. And then boost this to higher. If I can. Holy shit. But I'm not gonna plug this in yet because I don't know if I turned it the right way. Hopefully this charging thing is going to work. Okay, I went the wrong way. Of course I did. I don't even know if I'm spinning this. I should just get a screwdriver. Okay, I just realized I was measuring the wrong thing. Whoops. It's okay though. We'll measure it correctly now. $12 volts. Yeah, that's a lot of volts. I'm aiming for like 7 or 8. It doesn't really matter, but it needs to be at least 6. Because we're using the VN now. Okay. I mean, we can just leave it like that for now. It's definitely enough volts. So we're going to put this into the VIN. Okay, it's still not working, but... And now we'll check the 5 volts. And the ground. Maybe I have to wire the Arduino's ground. I'm gonna try that. That might be part of it. Even though, I mean, all the grounds are connected, but... Let's make them even more connected, I guess. And maybe we turn it off first. That wire's too big. Can I get a slightly smaller wire? Here we go. I don't know if that'll help, but I don't think it can hurt. So this ground is connected here, which is going through the voltage regulator and connected here. we've got 3 grounds going into, or 4 actually going into the negative track. Okay. Still doesn't work. Let's check the 5 volts. I mean, this should be. I don't see why this wouldn't be 5 volts. Yeah, that's coming from the Arduino, and then we're putting in 7.7 volts. We're getting out 5. That's to be expected. I'm trying to make sure the issue isn't the wiring before trying other stuff. Yeah, we don't want to short thing. Yeah. We can try USB power, sure. I'm glad I tested this first though, because like, this needs to work. My guess, assuming the hardware, the pins are all right. My guess is the code is somewhere in this code it's getting stuck. Oh, I mean, I guess I can do this. Oh my god, where's my keyboard? For all I know, it's working. Yeah, I mean, so it's looping through, so we are getting radio right. There is a data package. I mean, these sliders are just random. It's just completely random because like they're not plugged in, but so maybe I'm wrong about the hexapod. Maybe although I don't know, like what if, for example, what if I just like unplug any of the NRF stuff? Like if I did, it probably would still show this. So I still don't know if the issue is with the NRF chip or the code or, oh boy. Yeah, it's blinking. The TX is blinking because we're doing a serial write, I believe. And it's sending, like, the Nano's sending data back. Although I might be wrong. We can check. Let's see if it still blinks when we stop the comments. Yeah, see. So that blinking was the Nano writing. Okay, you guys can't see my screen, I'm realizing. This is a slight oversight. Sorry about that. So it's currently running right now, but it's not blinking because nothing is being written to. But if we go back to displaying the data, you'll see what it looks like, and it'll start blinking. So this is what's being written to. This is 6. This is 5. CSN is 5. CE is 6. I mean, it doesn't really matter what's here. It matters what's happening in real life. So like, I can confirm. They're like the same color. Yep, CSN is 5. All right, let's try something else. It's coming straight from the batteries. This should. Oh, it's actually not. Wait. No, it is. This is the battery's 5 volts. Okay, let's see. I just want it to stop right now. So... this track for the power should be 5 volts. Or 7 volts, whatever. It doesn't matter. The voltage regulator is dropping it down to 3.3. It should be at least. And it is. I checked. That's working. Let's make sure Mosey and Mizo. So Mosey is 11. Mizo's 12. God, I made all the wires the same color. And SCK is 13. Mosey is 11. Mosey 11, Mizo 12, SCK 13. That's what I did. Is there... I don't know. I think... I hope it has something to do with the code, but this is working. Like this... Okay, I want to try... not the antenna one. If I even have it. Wow, do I actually not even have it? I have another antenna one. What about this thing? You know what? Let's try that. I only buy 2. I have a breakout board for specifically the antenna. Let's try this. Let's try this. So I'm gonna just unplug this all. So I have this breakout board. Let me make my camera a little bit smaller. I have this breakout board that is for the NRF chip. It is totally possible that what I did is just wrong for some reason. So we're gonna try using this. VCC is indeed. Yeah, okay. Round 2, here we go. 2 by 3. Okay. want to drain the battery completely. What'd you say above? Can you plug this nano into your transmitter to see if the nano has working code? I can't. No, I can't. I mean, I probably could. I think I don't remember if I soldered this, but it's like deep. I really don't want to mess with this. If I really, really don't want to mess with this. Okay. Here we go. So it's the same code though. I'm positive it's the same code. I haven't touched this in a really long time. All right, this is power. Although now I don't need this little circuit thing, right? I don't need this at all. So I'm pretty sure I can just go directly with my battery's voltage. So I will. And this one has lights, so I'll know if I'll know if it's actually like doing anything. All right, let's make this one ground, of course. Let's start. Okay, what do we got here? 13. I remember 13. Just make sure that's wired up correctly. I remember 13 is SCK, which. MO and MI. I assume that's Mosey and Mizo. MO. One is 11 and one is 12. I don't remember. Okay. MO is 11, MI is 12. ERC is nothing. All right, and then CE and CSM. Okay, CE is 6, CSM is 5. CE 6. CSM is 5. All right, come on, here we go. Nothing. Alright, let's see if this works. It certainly looks nicer. We'll try. I mean, I know the hex bud's off. I just want to see if it lights up, I guess. Lights up. Okay. I wonder if the other light lights up if it like has a signal. Okay. Actually, I can look that up right now. So there's two lights. The one lit up with power. What does the other one light up for? I'm not sure if it'll say here. It has a power on SMD LED. Oh. Maybe it's just that. Maybe I miss. Yeah, that was a resistor. Okay, there's only one LED. Whoops. Okay, well, anyway, this definitely is more stuff, so maybe it'll work. Who knows? So here's my controller. You can see it working, and then I turn it back off. It does that. And then the new one. I'm gonna try my battery first. Nothing. Tragic. Just curious, is this breakout board doing what it should be? Or whatever it's called. So I'm going to attempt to measure the voltage. How about that? I think it's working, but it's hard to it's hard to get a proper, oh my God. Okay. It works when I touch it. That's not good. That's not a good thing. Jesus Christ. Seriously, it's working when I touch it. Okay. That's awesome. I hate this so much. What, like... Okay, well... What the frick just happened? Like, what actually just happened? Dude, I hate this. So would it have worked before if I touched it? I don't know. Alright. What just happened? This is so dumb. Man, it's so hard to like get a proper... Alright, let's go from the bottom. How about that? How about that? This is like using chopsticks, but worse. I think I just shorted it. Oh my God. Okay, 3.2. So it's clearly getting power, and it connected when I touched it for a little bit. Are you still looping? It is printing. That might not be good. It's constantly printing. Yeah, let's not do that because maybe it... I don't know. It definitely slows down the code. What did I want to do? Yeah. All right, let's try this. KiCad crashed on you 3 times in a row. Is the NRF in the transmitter in a socket? If so, you can... Yeah, no, that's a great question. I don't remember. I think so? Yeah. I mean, you'd think this would work. It worked with the battery. Alright, I'll try it. So... what you see, guys, what you see right now, oh yeah, you see it. It's constantly disconnecting. That's not good. And now it's fully disconnected. It's constantly disconnecting. keep in mind I'm using the breakout board. I'm not. Where do I have to touch for this to work? What is happening? Oh, you know what? It's also possible. No. This is really annoying. I'm using the freaking breakout board and it's, or the, you know, the board thing. Yeah. Yeah, you think it's a loose wire? Okay, wait, that's a hexapod issue. That's not the controller's fault. Okay, I have an idea. The battery's completely fine. I mean, it's possible the battery's not able to supply enough amps, but no, I mean, clearly it's, oh my god, wait. No, this is right. The breakout board is getting the power directly from the battery, which is completely fine because it needs 3.3 volts, and this is supplying more than that. And then this thing is powering the nano, which boosts it up to 7, which is also fine. I'm gonna try something. Don't do this at home, kids. Watch me, like, die. That would be awkward. Don't do this at home. I need a double-sided one. I mean, there's no way. This is gonna get really hot really quickly, but I don't care. I really don't care at this point. I just want to see if the battery's the issue, which I really don't think it is, but if it is, I'm gonna be sad, so. Yeah. Just be careful. Okay, well, that's garbage. Dude, I don't fucking care. Alright, here we go. This is the black. Goes into there. This is probably going to spark. We'll see. Oh, look at that. The battery isn't the issue. Huh. No kidding. Alright, screw this. It's not the battery. It's not the battery. This is 7.4 volts. It's not the battery. So what the frick is it? I mean, it's gotta be from using all these shitty wires, right? Should I just continue and like test the inputs and stuff? It has to be from these shitty wires. Oh, there was one more test. Yeah, okay, let's try this. So one more time. It does that reset thing because it's having battery issues. It's when it moves too fast. It doesn't matter. I can grab the NRF out of the controller and see if it works with my new setup. I'm hoping it's the wires, because if it's the wires, that means it's right. That means it actually works. Because if I was touching it and making it work, then, I mean, clearly that wouldn't happen with a PCB. I'm gonna look one more time for my other NRF. Well, wait. I think I only bought 2. I'm pretty sure I only bought 2. Hold on. Glad my camera's not overheating, by the way. I think I bought 2 of each. The 2 antenna ones and 2 normies. But let's see. Yes, I only have 2. So me looking for something I didn't have is not a great use of my time. I'm going to do some surgery. This should be fun. You guys get to see my handiwork. At one point, I thought this was going to be like what the final version looked like, or at least something like it, which is hilarious to me. It's hilarious to even think of, honestly. I mean, I managed to get it working here. It's the jumpers, guys. It's the jumpers. I don't think this is going to work either. There she is in all her glory. Because I remember this being finicky as well. You know, but like sometimes it would just stop working, which I'm not sure if what I'm doing is a good idea, but it's worth a try. Honestly, okay, so if this doesn't work, that's good, because that means they both will work with the PCB. If this one does work in my setup, that's bad, because that means the antenna one doesn't work, but the normal one does. Now, obviously, like worst case, we just don't use the antenna. But, I mean, and we don't need the range. I'm genuinely just doing it for aesthetic reasons. But regardless, I mean, it should work, right? All right, the surgery has been performed. Here goes nothing. I'm just making sure it's plugged in the correct way. Yeah, it is. Okay, you guys can't see the breadboard. Well, it doesn't really matter, but there it is. All right, here we go. I really hope this doesn't work. One wire at a time. I don't want it to. I guess you're right. But like, what if it's if it's multiple wires, then it'll never get fixed. It's the antenna one. That's working perfectly. It's the antenna. There's only one thing to try. I swear to God, if my other one works and this one doesn't, let's just, okay, hold on. We're gonna do some tests now. First off, I'm gonna edit the code so the default value is lower, because right now the joysticks are like, basically the joysticks are being pushed. I'm gonna edit the code, because right now if it moves to, if the hexapod moves too fast, it kind of like shuts down. I'm working on that, don't worry. But I'm I am going to change the default values. So that there's 0. No, 0? Yes, I think 0 is what I want. Because I think it's from 0 to 255. I don't remember though. Oh, I guess it's right here. Oh, wait, no, I can just do this. So, I mean, this is actually a lot easier than I thought. We're just gonna do a little overwriting here. I'm indenting it so it's clearly not the real one. So if it's 0 to 255, 0 is not what we want. We actually want somewhere around 120. I'm just gonna put it at 120 for everything, because that's in the middle, right? The button doesn't. The button. It'll default to 0, I think. And then this is, for some reason, 100 to 0, which it should not be. The controller should be just outputting 0 to 255 every single time. But whatever. So we're going to do 50. Well, what do we want? Yeah, let's do 50 and 50. That's fine. Oh, we gotta be a little bit careful, because when I plug this in, it's gonna actually like run, because it works. Or not. Oh, I think it's when I upload. That's it. Yeah. All right, here we go. So it should just start running now. It's concerning that it's not. Oh, because the power, it doesn't matter. It's because the NRF's power is coming from, the power track, and it's not coming from the Nano, which was powered. So never mind. Now, if this doesn't work, I will be more concerned, but... Good. So, first little test. Disconnect. Connect. Disconnect. Connect. Okay. Okay. Now we're gonna try hot swapping for the antenna version. So, disconnected, obviously. I just tore the freaking thing out. Okay, I mean, yeah, that doesn't work, clearly. I'm gonna be pissed off if this works. The other one. God, like, imagine if the issue was the antenna or something stupid like that. Oh, okay, well, I don't have to imagine. Let's unscrew the antenna. I don't know. Could be anything, I guess. Okay, and back to the old one, the working one. Okay, that's not good. Wait a second. Ah, okay. So that test wasn't good. Fair enough. They're not hot swappable. Fair enough. Okay. Maybe it needs the antenna. Maybe it needs the antenna. It probably does need the antenna, but maybe not. I don't know. Okay, so it connected for like a millisecond. Well, what? It keeps connecting and disconnecting. Just making sure you guys can see it while I'm working on this. That should be better. All right. This is so stupid. How is it a loose wire when the non-antenna one works? It doesn't make any sense. This doesn't need to be in the screen right now. On screen. All right, I moved the charger thing away a little bit. Are you serious? Okay. It's trying, like, I mean, this requires more volts, but like, I'm using the breakout board. Like, I bought them just to get the antenna versions working. All right, notice how this one's not disconnecting. This is exactly what I expect. All right. Okay, moment of truth. The other one. I highly doubt this will work. If this... Same thing. Same shit. This is so dumb. All right, maybe that means something. Like, when I disconnect it, it goes on, it connects for a split second. What voltage did you connect to the breakout board? Okay, that's a good question. Currently it's... it's 4... Oh, that's not good. Sorry, I'm just casually shorting the nano. Okay, that's fine. Jesus, this wire is like... Currently, it's the battery's voltage. Oh. Uh-oh. I think the camera finally overheated. It'll last for a little... Yeah, the camera... Okay, well, sorry, guys. Camera's overheated, but, I can... here, I'll make this camera slightly bigger. Or, oh, actually, I guess for the time being, we can just do this, which you get, like, a shittier view. It's the battery's voltage right now that's going into the breakout board. So it should be... I mean, I can show you. Well, I guess you won't be able to see it now, but... You'll have to take my word for it. The fact that I can't get the breakout board working is frustrating. You know, maybe I'm hoping that would be nice if it was just like a voltage issue. That, I mean, after all this, but still, that would be nice. So you see the white going in, you see the blue going in, and I'm just gonna do this. It's 4.1 volts going into the breakout board. So maybe it needs more. Yo, William, what's up, dude? Does it need to be 5 volts? It can be 5 volts. It can definitely be 5 volts. It needs the antenna. The version with the antenna definitely pulls more power. 100%. Do you have a 3-pin, Yes, I do, but I'm not using that right now. I'm using the breakout board. I was using it, and it was working perfectly, but I'm using the breakout board right now. So, because it is just one less thing to deal with. Well, multiple less things to deal with. So yeah, okay, I'm gonna try wiring the breakout board's power not from the battery, but I'm gonna do it from the 5 volt or the 7 volt. So now it's coming from the battery, the charger module thing, which is supplying 7.7 volts or something like that. But the breakout board's not the issue because it was working with the non-antenna version. No, you didn't. So am I wasting my time? Should I just assume it works? I mean, look, worst case, like absolute worst case, I just ship it with these instead of the antenna version. But I mean, I'd like to try to get this working. Well, continue to try to get this working. Okay, so now the breakout board is being powered by 7-ish volts. Let's confirm. .6 volts is what the breakout board is being powered by now. Straight from the charger thing. So, and it's clearly working. As you can see, it's freaking working. So let's try antenna number 1. Do we have any bets? Will this work? My guess is no. Because why would it? Oh my gosh. Who could have seen that coming? Okay. And back to this one. It works fine. And back to this one. Or not back, but like to the next one. That doesn't work either. All right, I don't know. You know, oh, you're saying it can't handle that much? Wait, but I bought the breakup board specifically for it. Oh my god. They weren't expensive, but still, it's annoying. What do you have the transmit power set to in the Arduino code? I do not know what that means. I didn't know that was a thing. What is that? What do you mean by that? The transmit power? I've never heard that before. So that gives me hope, to be honest. The transmit power. I'm not sure if this should be powered. Is this supposed to be working? What's it being powered by? It's being powered by V-in. That doesn't make any sense. I'm gonna put it back to the battery. power, which is 4 volts. All right, what do you mean by that? Radio.set PA level. Are level shifters designed to provide power also? I thought it only shifted data. I'm not using that right now. I'm not using the level shifter. I'm just using a voltage regulator. Okay, so what, line 61, what should it be? I mean, that might be it, actually. Set PA level. Oh. Set power amplify level and low noise amplifier state. This is not helping. Okay. So it can take 1 or 2 arguments, I guess. It does have LNA. It does have the LNA thing because it's the antenna one. Is this it? This could be it. It's fine as it is, but you can set the transmit power there. You already have it set to minimum so that, but I need more power. I'm thinking I need more power. That's, Wait. Is it because the antenna, what is LNA? Low noise amplifier state? I'm just gonna set that to 1 and see what happens. At this point, I don't know. The camera's off, so me pushing it like that doesn't matter. All right, I mean, it still works for here, so that for this one, so that's good. I mean, wait, doesn't it default to 1? Isn't that, it literally defaults to 1. God damn it. Maybe I should disable it. This isn't gonna do, nothing will change with this. This isn't gonna work. Nothing will change. Sorry, wow, I'm, frick. All right, gotta chill with this battery. All right, let's set it to 0, I guess. I don't. Maybe I should look something up. The LDO. What's LDO again? The breakout board was made for this though. Okay, sir. Maybe, I mean, I don't know. I don't know. I'm gonna look. If this doesn't work, I'm gonna look up a tutorial. The breakout board is literally made for this, which is frustrating. I'm gonna set this to 0 and see what happens. I don't really care at this point. It uploads so fast. I've been used to just waiting forever. All right. So this might not work. I am unable to push it in. That was weird. Now this might not work since I actually changed something. Oh, no, of course it works. I hate these antenna things. By the way, I've never been able to get one working, ever. But, I mean, I've only tried like once. Okay, I don't know what I expected. All right. I give up. We're looking up a tutorial. Let's see what I'm doing wrong. Arduino NRF. Normal works, antenna doesn't. Oh, cool. I have no internet. All right. Okay, we can try that. Maybe you're right with the capacitor. What? You guys can see the screen. What? Wait. Okay, I don't... Okay. Very important. Especially if it has the ampli. Okay. You might be onto something, even with the breakup board. He uses a 4.7 UF. I was using, I believe it was 10. Yeah, 10 UF. Oh, this is 100 UF. Jesus. Wait, why? Both of them? Oh my god. I did this. The amplifier can use 100 milliamps. Okay. Man, I think this is just like... I think I'm just not going to use the antenna one. I'm gonna just add a little fake antenna and pretend it does something. I think it's the capacitor. I don't know, all the tutorials on YouTube use the antenna one and it worked for them first try every time. So the cap needs to be close to the power inputs of the NRF. All right, let's try it. I mean, it was, but oh, I guess it was going through. Oh. The capacitor, I know. Okay, this is worth turning on my camera. The capacitor was close, but then I have the signal travel through a jumper. Oh my god. Okay. It works. We all saw it work with this version. Worst case, no antenna. I just use this. That's worst case. Best case, the PCB it actually works once you shove it in the PCB. I'm gonna have 2 decoupling capacitors. I don't know what else to do, so I'm not gonna break out the oscilloscope. I'm just not gonna do that. I have one, but right onto the power pins of the NRF. You want me to try that? I can try. So that's a good idea. I'll be right back. Where is it? Here it is. All right. 10 UF, 50 volts. So that's what we're doing. It has a 1. Yeah, there shouldn't be any problems with the voltage. Okay, thanks. Doesn't get any closer than that. Probably. Oh my goodness, man. What a pain in the ass. Nice. Oh my god, please. Like, just beautiful solder job right there. Like, genuinely the best I've ever seen. This is not sarcasm. Okay, here we go. Should I put the code back? Should I? Did we get a consensus on whether LNA should be 0 or 1? Oh my god, stop. I have no idea. I don't know, whatever. All right, here we go. I mean, obviously we tried this one first. Why wouldn't the breakout board have a capacitor? I don't understand. I don't understand. All right. Yeah, that's clearly working. All right, this has a freaking capacitor directly on it. It's a 10 UF capacitor, 50 volts. Are you fucking kidding me? It works. It actually works. Wow. Someone give Wagon Loads like a round of applause or something. I don't know. Wow. All right. Well, You heard it here first. Soldering the capacitor directly to the NRF chip works perfectly. I think I just want to end the stream here. I'm not gonna lie. Thank you, Wagon, for that. That is smart. That's very smart. I wonder if this would even work. Like, so I was planning on putting the capacitor on the PCB. What if, like, you had to do it like this? What if you had to have, like, what if it wouldn't work in the PCB as well? You had to solder it directly there. I don't know. All right, well, let's wire everything else back up, I guess. That only took like 2 hours. Holy shit. All right, here we go. Hopefully the camera doesn't overheat. So we don't want these. These were from the raw battery, okay? We want to go from this, which is the V out of my voltage regulator, into this. This is ground. Works for me. All right, what else we got? At least I can like match it up. So this is CE. CE. Sorry. This is CSM. This is SCK. This is Mosey. Last but not least is Mizo. Master in, slave out. All right. Okay, if this works, how long have we been streaming? It has felt like 6 hours, but it's only been 2 hours and 50 minutes, but holy crap. All right, here we go. Here we go. So we've got our capacitor for the voltage regulator. We've got our capacitor, which we were missing, for our NRF chip. I mean, everything else is probably great, I'm sure. Let's try it. Also, if you're curious what happens when the wire's short, nothing. Okay. It's not a high enough voltage. Hallelujah. Oh my goodness. This is my no breakout board. This is my custom shit right here. I say that. It's literally just a voltage regulator. Dropping it down to 3.3. It's working. Clearly it's working. We can actually move on. Oh my god. Oh, was that you, Brick? I thought it was Wagon. Wait, okay. No, that's true. You said you're right. I remember. You said to add the capacitor, and then Wagon said to solder it directly to the NRF. So it was a team effort. What's up? Can you give some quick tips on getting transitions and rotations working? Dude, I would love to do anything but this, so sure. Let me put my controller back together first. But so by the way, this is fully working. This was the only NRF test I wanted to do. All the other tests for like the screen and the encoder and just everything and the joysticks, they don't need the NRF. I can just test it with like serial prints, probably. So I just wanted to make sure this worked. And now it does. Now it does. So I'm going to take it all apart. Okay, that was not as cool as I expected it. All right. Alrighty. I have confirmed that this wiring does indeed work. Here's my little voltage regulator. So, holy shit. Nano stays. Nano stays. Should the, yeah, I think the battery thing should also stay as well. But yeah, I'll go through my code. Well, not through my code. I'll try to just explain my thought process. Okay, I want to keep this. That's battery in. Voltage out. We decided to make it 7 volts, even though probably should just keep it 5 volts. I'll change it later. Although you know what, now that I think about it, I like the idea of bumping it up to 7 because it's possible that maybe it doesn't work perfectly and it goes too low or something. But if it's 7, I feel like I can trust the Arduino to output the correct voltage. So I don't know, we'll see. There's a wire on the ground. Okay, anyway, we got this. I said I was going to reassemble my controller, just make sure I'm back to where I started. Look at this. Abomination. Oh my god. Alright. If this doesn't work, I'm going to be very disappointed. That was a longer delay than I'm comfortable with. It's because it's not screwed in, most likely. Oh god, okay. Maybe I can just do this later, honestly. But you guys have suffered enough. I think I used tweezers for this when I did it originally. Not a bad idea. The new controller is not going to be using these type of screws, by the way. Absolutely not. Oh. I don't know why. I don't know why it's such a long delay, but whatever. Okay. Okay. I don't care at this point. Yeah, no, I'm not trying because it doesn't work. I've already tried. I don't have a voltage regulator in there. I'm just pulling directly from the 3.3 of the Nano. Alrighty. What was I doing? That's right. Okay. Jesus. God. Stop. Thank you. All right. So what did you ask? All right. Can you give some quick tips on getting translations and rotations working? Translations. So do you have inverse kinematics? I assume. I hope. Help you out by letting you pat yourself on the back. Yeah, Brick. Do you have IK working? I assume. So you just want to like know what's going on with like the actual walk cycles. Okay. All right. Let's see. Okay. Let's see if I can find it. Not that. Oh my god. Okay. I mean, it's probably car state, but I want to open all of those. I don't want. Okay. Well, there you go. So, oh man, rotation. The goal. Okay, so translations. You just want to like move it. Yeah. Okay. The thing is, like this code is like, I've iterated on it so much. It started out with just making the foot follow a straight path, and it is it's turned into something like it basically dynamically calculates the walking path every single loop, and it updates based on what your joysticks are doing. So I don't know if this is going to be like readable to, or even like comprehensible. So this is my awful way of managing the different walking cycles. So this should not be here. This should be in a different file. But yeah, it's just a switch case with different numbers. These make sense to me. They probably don't make sense to you, but basically how this works is like, I know you didn't ask about this, but so points. Well, actually, this is kind of answering your question. So the walk cycle is broken up into two segments: the moving along the ground, and then the lifting and bringing back to the beginning. All right. And I break it up into points. Initially it's just 1 point in the beginning of the walk cycle, 1 at the end, and then, an arc. And I break that up into well, I can tell you. How many points do I break it up into? I don't know. There's a number. 1,000. Completely arbitrary, but it really does not matter. So 1,000 points. So these two paths are broken up. So this is broken up into 1,000 points. Okay, we're not using all those points. It's completely arbitrary, but so 1,000 divided by 2, the cycle progress of leg 1, or I guess leg 2, is 500. So it would be 500 out of 1,000, halfway. All right. So I start legs 1, 3, and 5 at the beginning, and then I start legs. This is for the tri-gate, by the way. I start legs 2, 4, and 6 halfway. Great. That makes sense, right? How do they follow the path, though? That's down here. This might be easier to read than I thought. Right. So the whole thing is just moving the legs, moving the feet, the legs, endpoint, whatever you want to call it, to a certain position. What is that position? That's the question, right? I have a function called getGatePoint. Awesome. What is push fraction? I don't remember. Ah, okay. Really quick, push fraction is the amount of time, rather the fraction of the entire cycle that the legs are touching the ground. So again, it's broken up into a single walk cycle is broken up into two, separate things. The flat part and the arc. So the push fraction is the flat part, the amount the leg is pushing along the ground. So for most of these, it's half, but for some, by gate, for example, it's only a third. I don't know. Typically, you want it slightly above half, but again, you can just mess with it. But anyway, get gate point is what you're interested in, I assume. So we have the leg, we have the push fraction, we have the center offset. I don't know. I don't even know what that means. Okay, that has been depreciated. That has been depreciated. It is not used anywhere. So, what the fuck? Okay. I can delete this. Okay. Anyway, so get gate point. You input the leg, you input the push fraction. There's other stuff it uses though. There's other stuff it uses. Which is, again, this code is not neat. Let's see. So it's getting the stride length based on how far you're pressing the joystick. You don't care about that right now though. This is just getting like the joystick stuff. Okay, this is important. So as I said, it's broken up into two parts. Pushing or propelling and lifting. T, this is the other important thing. What is T? This is T. T is time. T is, I don't, it's like which point you're on, basically. Right? What the hell is T? I think it's a number from 0 to 1. Yeah, it is. Okay. It's a number from 0 to 1. T is like 1 being the walk cycle's done, 0 being it's just beginning. So if T is less than the push fraction, you're pushing. You're on the ground. It's straight. If it's greater than the push fraction, obviously you're not. So you're lifting. These are two different equations. Like you can't get the point of the walk cycle with one equation. It's a line and then an arc. The line is much simpler. The arc is annoying, but it's not that much harder. But so just imagine a line in space, and we need to get a point on that line. Okay? We need to get a point on that line. I am. I'm trying to relearn how this works. Right, okay. Rotate control points. There's two separate lines. One line is if you're going dead straight. If you're just walking in a straight line, it's a line, okay? If you're turning, then it's a curved line. These control points are creating a Bezier curve. Now, obviously, if there's only 2 control points, it's going to be a straight line. But if there's 3 control points, it's going to be a curve. I'm just making sure that I'm understanding this correctly. Oh, okay, okay, okay. I'm calculating both, all right? I'm calculating both. And depending on how... Yes. Yes, 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 yes. Okay. I'm calculating the straight walk. I'm also calculating the rotate. And depending on how hard you're turning, it is how much they... Like, I'm averaging them together. This is where it's getting a little complicated. But basically, I'm calculating the straight line, and I'm also calculating only rotating in place. All right? So, for example, left joystick is strafing, so it's straight line. Right joystick is rotating in place. But you can do both at the same time. I'm calculating both. This is only caring about the right joystick. This is only caring about the left. I'm averaging them together here. And that is what I'm returning. 1 point. All of this for a single coordinate in space. 1 3D point. This is obviously a Bezier curve in 3D space, if that wasn't obvious. Right. Yes. Yeah. So I mean, I'm assuming you know how to get a point on a curve or a line. Obviously, I'm brushing over that part, but like I have a helper function that I found. It's not hard. Bezier curves are. I mean, I don't understand how they work. I don't need to understand how they work. I literally just looked up how to make a Bezier curve and then how to get a point on a Bezier curve. You just need control points and then you need one function to get the point. And these obviously use the same equation. So it's the control points, and then I input how many control points there are, because sometimes there's 2 and sometimes there's more. And then it's a number from 0 to 1 based on the push fraction, right? Now, yeah. Yes. Okay. It does get a little more complicated here but it doesn't matter. This is the general idea. It's the same idea for the lifting. It's just a little more annoying because T is actually so for propelling, T is from Z. This is where it gets a little weird. From propelling, the first half of the walk cycle, T. Remember, T goes from 0 to 1. T actually is only going from 0 to to T divided by the push fraction, I thought. How does this work? There's X, and then there's min, and then there's max. So why is yeah, of course, push fraction is the max. Right. So let's say push fraction is 0.5, right? I don't want to map this. I'm not getting a number from 0 to 1. I'm mapping it onto from 0 to 0.5 because I'm only looking at the first part of the propelling of the walk cycle, which is the propelling. For the lifting, notice how it's different. It's the min is push fraction, and I'm going to 1 because that's the second half of the walk cycle. But regardless, all you need to know is what I already explained, and you're just returning a point. You're returning a point on a line. Now, in my case, it's a little more complicated. It's the straight line averaged with, or rather, I'm sorry. I'm not averaging the lines. I'm averaging the points. I'm averaging the points. That's interesting. I think I actually have an equation for that. Yeah. So I have a vector 3 class, which is just 3 numbers, and normally you can't divide like that, but because I have this, the divide operator, I can. I'm wondering if anyone is following this right now. I'm not looking at comments on purpose. But yeah, so straight point, this is a vector 3. It's 3 numbers. I'm adding it to the rotated point, and then I'm averaging them together. It's a weighted average. Because it's a weighted average. Is it a weighted average? Because I'm multiplying by this first. No, this is just the sum. Where do I count? Yeah, I'm just oh. I don't know. It doesn't matter. I'll comment this code eventually, but you get the point. Hopefully. But yeah, so that's strafing plus rotating in place. I can't demo the hexapod right now because one of the motors just doesn't work, and I don't know why. I'm gonna read the comments. Okay, there's only 2. That's good. That's good. Does it stop? Does it work if the step is walking back? Yeah, of course. Yeah. That's a good question. So how does backwards work? I don't. Oh, yeah. Right here. This is why backwards works. So I'm every loop. I don't like calculate the entire step. Well, I technically do, but I only care about one point, right? Every loop, I recalculate the step. Okay? So if you suddenly start going backwards, one second. I recalculate the step starting from where the leg previously was. So if I'm going forwards, right? I'm in the walk cycle, I'm going forwards, and then I start going backwards, it starts the step calculation from here. It starts where it left off. So it doesn't like jerk around. It used to. That was annoying. But yeah, so that is handled. That's a good question. I want to see what's wrong with this. Oh my God. Okay, good news. The servo didn't give out. The pins just got horribly bent. Wow. Okay. I can demo it. Give me a second. Give me a second. You can try to watch if possible. I need to take the top off. There has to be a better way to do this. Oh my goodness, how did that happen? All right, hopefully they bend back. not sure how many more times that can happen, but... Too short. Oh my goodness. Okay, if it gets caught, it's too short, but otherwise it's not. Huh. That's interesting. I see how that happened. Well, shit. Alright, does it happen with any of the other ones? Why wouldn't it happen with the other? What the hell? Why is this wire so short? Oh. Oh my goodness. Okay. I'm gonna have to rethink this design a little bit. Alright, well, anyway, I can test it, so. Let's do that, oh man, what a stream. I will definitely organize those. Definitely. Alright, can you see it? Yeah, you kind of can. We should probably check the battery's voltage. I mean, it's... I don't have any other way to check it aside from just shoving 7.2. Jesus. That is very low. Okay. To be fair, I haven't charged this in quite a while, but... Do I have a bat? I swear to God. Well, let's check this one. This one's basically dead too. Holy shit. Is there a battery in this guy? No. Okay, where's my last battery? I think I put it over here. Oh, it's on. I did put it. It's on the ground. Okay. Now this is the big battery, so if this one's dead, then, well, I'm going to be really sad. I don't think this one's dead, though. Yeah, this one's full. This guy's full. All right. This is the nice one, the 72 milliamp one. All right, are you ready? Holy shit. So... you can see what I'm doing. This is only left joystick. So notice how it's walking in a straight line, but I can dynamically change the direction mid-walk because it's constantly updating. And then, okay, let me get it. I can't control this by looking at the screen. Holy crap. I barely can control it. Okay. Okay, so now this is rotating. This is only the right joystick. Okay. And then let's make it face forward. I think that's forward. So now you can combine them. I'm gonna go really slow. So I'm using both joysticks. And it kind of drives like a car, only I gotta watch it, I'm sorry. It kind of drives like a car. So forward, backward, but then you can like turn while going forward. It's not perfect because like when you're averaging them together, the steps kind of get shorter. But okay, and now I'm gonna make it go faster. But this is so currently I have an issue with the battery, or the battery eliminator circuit thing. These cheaper servos require a max of 7 volts, and the battery is outputting 8. And the way I'm lowering the voltage is currently not ideal. So, well, look what happens when the amp draw is too high. Okay, so that actually works pretty well. Let's... There. That's what happens. To be fair, it lasted for quite a while. Interesting. I'm trying to change the height as it's walking. It's kind of hard to do, but it does work. It probably could work better. And then max speed, if I put the max speed all the way down, I like this because if you're like letting someone else use it and they don't understand how sensitive the joysticks are or can be, it makes it so they can't like crash it. They're different. Oh. We don't talk about this gate. So this gate is what happens when you don't offset the legs. They're in sync. That's Ripplegate. No, that's not Ripple. That's Spidergate. I don't remember what I called it, but it's basically Trigate, but all the legs are like out of. They're all offset. This is Ripplegate, or this is Wavegate. No, one's Wavegate, one's Ripplegate. I think this is Wavegate. So this in this gate, the push fraction is 5 out of 6. Does that make sense? So for 5/6 of the entire walk cycle, the leg is on the ground. Okay. Does rotation change which legs are the front legs? There are no front legs. Basically, I mean, yeah, I guess there are front legs. So going forward, there is a forward, right? But like the walk cycle doesn't know about that at all. That like the front legs aren't special, I guess. So that question is kind of weird. How do you code moving the body while the leg tips are fixed? I haven't done that yet. I don't know how. It shouldn't be too hard, but maybe, I don't know. It seems annoying. I haven't done that. Yeah, it looks like it's stretching. Yeah. So theoretically, how I understand it is, oh God. If you move that might work. If you offset the end point of every position for every leg, if you offset it the same direction, that would make it shift around, right? Yeah, it would. But like how, like to tilt it, there's some more math that I haven't done that I don't want to do, but maybe I should. I mean, what if you just rotated all of the endpoints? I don't know. I didn't do it yet, so. You lift everything with all legs and don't carry the weight of the hexa plus any additional weight all the time. Oh, what, with all 6 legs walking at the same time? Is it possible to move only the body without? Yeah, so it's possible. I just haven't done it yet. Although, wait, I did one time make a gate on accident where like no steps were being taken. It was kind of funny. I wonder if like stride length, if I put it to 0. I don't know. I don't really want, I don't know. Hop gate, yeah, everything starts at the same. You need to make it so it can sit on the charging dock. Right now there is no charging dock. It's just you replace the lipos, but that would be awesome. If it was like a Roomba or something, yeah. Is there a center point set in the code? Kind of. I'm not sure. I know that so basically each leg has its own like starting point. Hold on. Oh, here, rotation multiplier. Okay, so yeah, that's what I thought. How do I say this? you can think of each leg as having like its own local grid, and then, is that true? And then I basically rotate it to, depending on which leg I'm working with, I rotate it like 55 degrees one way or the other. So that all the legs are moving in the correct direction. But I don't necessarily do that. For example, when you're rotating, so when I'm calculating the rotation curve, I don't need to rotate, because like I just want the legs to move in a curve. But for straight, what I do is, so like, okay, the hexapod, right? This is the body of the hexapod, and then you got legs coming off, okay? So I calculate the straight line walk of all of the legs, right? And then after the fact, or during the fact, I mean, you saw the code, I rotate it. So like this leg would get rotated so that this line faces this way. This one doesn't get rotated at all. This one neither. This one gets rotated so it faces this way. This one so it faces this way. But like, as for like the center of the center of the hexapod, I don't even, the centers are all, these are the centers. Like I only care, because I don't remember if I rotate around this or if I rotate around this. I'm pretty sure I rotate around the foot. But why would I rotate around the base? That doesn't make sense. Yeah, distance from center. Yeah. So, what is distance from center? 190. Okay. This is not the distance. You can't see my screen. Holy shit. This is, let me go back to what I was showing. So, right. Let me just really quickly. So as I was saying, for calculating the points for when you are rotating the hexapod, I don't touch that point. I don't do anything to it. I just find the point. For a straight line, for the straight line point, I rotate it depending on which leg it is. Okay? Wow, I was doing amazing pictures and you guys couldn't even see them. Shit. Okay, well, whatever. I rotate it depending on the leg, right? So back to my picture that you guys didn't see me draw. Here. First, I find the straight line of each leg, and then depending on which leg it is, I rotate it. So like for this one, I rotate to the left a little bit, 55 degrees. For this one, I rotate to the right, 55 degrees. These two, I don't rotate at all. So hopefully that makes sense. And then as for the center, so, why did I do that? You see, so I'm rotating. What is this function? Angle, right? Okay. This is the rotation angle, and then I'm rotating around this point. So I'm taking. Right, this makes sense. Yes. So I'm taking my line and I'm rotating it. This isn't exactly what I'm doing, but it's basically what I'm doing. I'm rotating it around this point. What is this point? Distance to center? Well, no, it's the distance from the center is actually this. I'm pretty sure. I mean, I guess functionally it doesn't actually matter whether it's this or this. But like the center of the hexapod isn't really, I don't even know. Is this 190 or is this 190? I don't actually know. It might be this. This might be 190. But it, oh, does it matter? I'm pretty sure it's, I'm like 95% sure that the center is this, where the coxa joint is. Right. Does that make sense? Yeah, what is that variable? Yeah, because Steph, you're actually looking at the code, so this might actually help you. But yeah, so I'm fairly certain that is what distance from center is. Which, I mean, it's just like a hard-coded thing. Yeah, it's just a number. It's just 190. I can show you what it looks like if I change it, by the way. I mean, it just makes the legs closer together. It's not that hard to understand. But yeah, I should comment this code. Man, I wanted to do more today, but I'm kind of just exhausted from trying to get that NRF chip working. Maybe you know what, we can do something more peaceful though. Maybe the encoder. I don't really want to. Well, yeah, the encoder. Maybe the level shifter. Just trying to get the level shifter, or shift register rather. Trying to get the encoder working through the shift register. I wonder. That's gonna be annoying. Yeah, hopefully some of that made sense. If you have an X and Y center that we can move, that should work. Right. That's a good point. Okay. Well, I guess if you dynamically change the distance from center depending on which leg, that would work. Or all of them, actually. No, depending on which leg. So, oh man. Like, let's say you wanted the body to move like here. I mean, isn't that functionally the same as just moving the endpoints? Like, why wouldn't you just offset the endpoint by a vector? What's the difference? I don't know. I'm not like. I feel like inverse kinematics should be able to solve that. James Bruton does it so easily. He always makes them dance, but I don't know. I never really tried. Like, I have. And by the way, it's Bruton. I just like saying Bruton because it rhymes with crouton. But where's my inverse kinematics? Did I actually put it on the main? I actually did. Wow. Yeah. So, I mean, these are the inverse kinematics. You put in a position, and you put in which leg you are, and it moves the servos for you. So, I mean, what would you need? Like, how would you make the body tilt? You'd be changing, like, I feel like the way I want to do it is severely overcomplicated compared to how it could be done. I'm not sure. Yeah. Like, I put a plane, I tilt it, and then I raise and lower the feet. Oh, that would actually work. I create a flat plane, right, in code or whatever. I tilt it however you want, and then I raise and lower the endpoints of the feet to match that plane. That would work for tilting. That would actually work. I see it. And then for like panning or whatever, that's easy. You just offset the end position however you want. No, so I know the endpoints should stay the same, but I'm thinking like, okay, if you offset the end position of all the feet, the body's gonna move, right? The feet are gonna stay in place, the body will move. It's the same thing. You know what I mean? Thanks for the explanation. Love the aesthetics of your bot, by the way. Thanks, man, I appreciate it. And I'm glad, well, I'm glad you liked the explanation. I'm not sure if it was followable, but. You 3-printed, you made the mini hacks? Nice, very nice. Did you post it in the Discord or? Well, if you didn't, you should. If you did, I'm not good with names, but you know. Yeah, it is fantastic for visualizing, actually. It is really good for that. In void, move to position, you have float x equals position x, float y. Let's see. Yeah. That's interesting. What is position? Oh, these are just like, these are the end positions, right? This is the goal. This is what I'm going for. So I guess. I guess I could just add, yeah, whatever this is, for moving the body, like, not tilting it, but like moving it. I could do that. I could just add the offset to the feet. And then what about, there's tilt, there's move, and then there's rotate. God. It's so annoying. The only point to add this is because it looks cool. That's the only reason. How would you tilt? Or rotate? I mean, to rotate, you would just, it's the same as strafe. You would just offset all, wait, would that be right? I think. Yeah, you would just offset all the feet positions in like a curve. on a curved line instead of a line. Oh God, no, hold on. I'm having trouble visualizing that. The straight one's moving it like laterally or whatever is easy, but to twist it, to rotate it, how would you? Each. I know where I would do it. I don't think messing with this function though is a good idea. In fact, it's not. You shouldn't touch this function. You would do it just wherever. I mean, I guess it would be its own mode, right? It doesn't have to be. You could definitely walk while doing this, but there's not enough joysticks for that, to be honest, but you would do it here. You would do it here. Yes, 100% you would do it here. You would just be editing this point. Yeah. So I'm pretty confident I can do it. I just have no desire to. When I do that, it's after the code is going to be cleaned up. Match the tilt angle of the joystick. I don't know about that. Oh, but yeah, I'm going to add a gyro into it, right? So, oh, that would be a fun test. I already connected the new controller to it. What if I wrote some code to like make it match the gyro? Oh, that, you know what? That's actually shit. Now, okay, so the gyro can tilt. It won't be able to move forward and backward, but I don't really care. Just matching the tilt would be really cool. That would be really cool. So yeah, I'd create a plane in 3D space, make the plane match the tilt of the controller, and then alter the final point up or down to be on, to intersect that plane. I don't think I'm overcomplicating that. But I'd have to make the point in the dead center of the hexapod. I'll have to figure that out. 190. I think distance from center is... I don't know. Never mind. I still don't remember. Okay, guys. I really wanted to do more of this stream, but I've spent almost 4 hours trying to get this NRF chip working. Obviously, the last half hour was not that, but yeah, let's end on something peaceful. I am going to implement. What am I gonna do? How about we do the rotary encoder? How about that? How about we do that? That sounds fun. You worked on my RC transmitter PCB. Did you really? You want to send that to me? Dude, that's awesome. Thank you. 0 errors or 0 warnings, or both, or errors probably, but still, that's awesome. Oh my god. Send that in the Discord, please. I'll upload it to GitHub. All right, rotary encoder. Let's do it. What does that need? Maybe not. We'll see. Oh, but it's going to be through the shift register. All right, that's a whole thing. All right, let's do the rotary encoder, but not through the shift register, and see how annoying that is. Yeah. So let's do it. What game am I making? Oh man, kind of like a real life game, Matzi. I am making, so you might think I'm game dev because my Twitch is a little outdated. I'm making a hexapod, but like, yeah, the game of life. But in real life, I just demoed it. If you want to go, well, if you go to the YouTube stream, you can rewind. If you scroll down and go to Acer Robotics, you can see what I'm working on. But I mean, oh my god, here. There it is. Now you can actually see it. I'm not gonna demo it again though. No, I already did. I'm sorry. But okay. If you really want to see my demo, that was like 10 minutes ago, you can go to the YouTube stream and rewind. Or just watch my YouTube videos. But anyway, I want to... So we've got this. What is happening here? Right. I want to get this rotary encoder working. So the breakout board already has the 2 resistors that are right here, off of A and off of B. I'm just going to attempt to confirm that. Wish me luck. Yep. And yeah, I think so. Yeah, well, okay, anyway, don't need resistors. So we've got the clock. You can't see that anymore. We've got the clock. It's upside down. Oh my god. Okay, we've got clock, DT, SW, plus, and ground. The switch is the press button, so I don't care about that. Clock, DT, plus, and ground. Okay, so let's connect the clock to, and then, I mean, I don't want to do the interrupt pins. I'm just going to do, oh my god, D5. Okay. Okay, so the clock is on 5, and whatever DT means is going to be on 4. Hopefully those aren't interrupt pins, but I mean, if I don't set them as such, then it's fine. And then, okay, power, this needs 5 volts. We've got that somewhere. I'm just looking for wires. All of my wires have been taken up by the NRF thing. Okay, this is 5 volts, I think, right there. Okay, and then we need ground. All my wires are gone. I'm just gonna grab one from here. It doesn't matter. We'll use the ground of this. Oh, yeah. It does. It shouldn't matter, so we'll see. All right, so we've got that hooked up. What's the next step? Well, the next step is to code it. Do I remember how to code it? No, not even a little bit. That's okay though. Because I can just go like this. Arduino EC11 tutorial. Although there is something I'd like to try first. There's a library. I don't know if it might be this one. I've actually done a small project using these, and I'm gonna try to find it. Digital dice. Here it is. Okay. Include T and oh, that's the screen. Encoder. It's just encoder. So this is what I use. So let's install that. So I can copy my own code. I can copy my own code. So you create a new encoder. Sure. I had 2 of them in this project. So let's just do this. That's fine. What the heck? There we go. Right, so we create a new encoder object. Let's see. Okay, we need to save the previous position. That makes sense. I mean, let's just so the encoder can be like 0, 1, 2, 3, or negative. So this is saving its previous position. Although now that I think about it, I think this was project specific, because I made, it was digital dice where like it like rolls dice for you. You choose how many sides you want your dice to have, and you choose how many dice you want to have, and then it rolls. So I guess I'm not sure why. We'll keep this for now. I think we need it. It's hard to say. Okay. Quantity switch pin, side switch pin. I don't want the switch. We're not doing that right now. Maybe I want the switch. All right, we'll do the switch too. It's good. Because we'll do the switch because the controller is going to have a switch, so we might as well. Might as well. We'll do that on 7. Or 6, rather. All right. Does the switch pin need to be a pull-up? It does. Right. Because I'm not using... Okay, that's fine. So in setup, we're setting the switch pin to be a pull-up. So I think what that means... What the frick does that mean? It means it's always high, and then when you press the button in, it becomes low, or vice versa, something like that. Fair enough. And then this is for screen stuff. I don't care about that. Let's do the serial thing because we're going to be using that. Alright, I'm pretty sure that's all we need to do for this. The encoder sets itself up. We don't have to do anything for that. Check button. Is that checking? Right. Okay, so this project had like a button that I could press, so that checks that. But I want... We're not using interrupts either, so keep that in mind. Okay, I think this is reading the switch of the encoder. So let's check that out. We're putting this in loop. So let's see, side switch value. Yeah, like how many sides the die has. But this is just going to be called switch value, and then we're reading the switch pin. This all makes sense so far. If the switch pin's value is low, sides equals 1. Why? I don't understand why what is sides? It's supposed to be the amount of sides your die has. I'm not entirely sure. Let's but I am pretty sure that this is sensing the press of this switch. So let's do serial.print new line. Can we just print the switch value? I guess we'll find out. All right, this is like as simple as it gets. So if this doesn't work, it's gonna be kind of depressing. But again, I haven't coded Arduino in a very long time, so we'll see. I don't think you guys need to see this right now. Hold on. Oh, also, do I even need this battery thing? I can just power this from the Arduino, right? Although, should I? Okay, that's what I'm gonna do. Yeah. I'm gonna power this from the Arduino. I'm not gonna use this. Although, is that really a good test? That's not a good test. No, we're gonna do it right. We're gonna do it right. So I'm gonna keep it as is. Let's upload this code. I hope it works. There's not much to mess up. Okay, so it should constantly be printing the switch value. Okay, and if I press, well, there you go. All right. So if you press it in, and that is what I said for the record. If you press it in, it becomes a 0, and unpressed, it's a 1. Works for me. All right. Now, what I could do is, this is why it was if it was low. If switch value equals low, then you print the switch value. But I could just print pressed. Maybe switch pressed. And if we upload that, you'll see it constantly does that. Now, I don't want that. I don't want to have it do that. I want to just have it once. I just want it to press once. How hard is that going to be? That's where the previous value comes in, I bet. Did I end up using that? Where the hell is that? Oh. Oh, never mind. That's previous position. Well, anyway, let's see. Let's think about this. Can we do bool switch pressed equals false? Okay. If the switch is low, we pressed it, right? So switch pressed equals true. Well, first let's print, set it, and then set it equal to true. But this isn't all we want to do. We only want to print if the switch wasn't already pressed. So we're gonna do another if statement. Let's do this instead. If switch value equals low and the switch wasn't pressed, okay? Print switch pressed and change it to switch pressed. If switch value equals high, which means it's unpressed, and the switch is pressed, switch is released. And maybe we're not as happy about that. Okay, let's try it. Let's see if this logic works. Can we clear? Yep. So I press it in and hold. Okay, so that clearly did not work. Yes. So what's happening is it's doing this, right? And then it's just checking for this, which, yeah, right? But no. No, it should be else. It should be else. But how was the switch value high? Hold on. If the switch value is low, that means it's pressed. This is not complicated. If the switch value is low, that means it's pressed. My camera was on and overheating. So high means it's... Do we even need this Boolean? I feel like we do, but I'm not using it correctly. If I'm tired, holy shit. If switch value is low, it's pressed. If switch is high, it's unpressed. So if the switch value is unpressed, but it thinks it's pressed, why was this constantly printing? If switch value is low, which means it's pressed, and the switch is not pressed, switch press. Jesus Christ, I hate C++. I hate C++. I hate C++. My logic was correct. Oh my god. Okay. There you go. I'm holding it. I'm releasing. I'm holding it. I'm releasing. I'm pressing it really fast. I'm sure someone had to catch this. Did no one catch? Okay, fair enough. My God. Thanks, Motzi. I appreciate it. I'll see you later. You probably are already gone, but just know that I said goodbye. You have a special place on Discord for me to upload the PCB. Put it in the hex general. Put it anything related to the actual hexapod should go in general, ideally. Oh, is it Christmas music? Yeah, let's thanks for letting me know. Okay, I think if I play it from here, it'll play in this order. It is so late for you. Have a good night, Suzuki. Oh my god, it's like 6 a.m. for you. Yo, Steph, you were able to port it. Very nice. Porting of your RC code, porting of your code to RC control is done. Nice. That's awesome. I just need to print a mount for the electronics, and you should be good. Hell yeah, that's really exciting. Nice job. Wow. So I think you're gonna be the first person to do it, to get the hexapod working with custom electronics, as opposed to Arduino like I use. That's awesome. 7 a.m. Oh my god. Nice job. I can't wait to see that. Okay, so we got button pressing. Oh, and by the way, why am I saying like I hate C++, whatever? Because any other language, it would have been like, hey, this doesn't make sense. double equals here doesn't make sense, but whatever. Okay, now to sense the twisting, the turning of it. Well, let's see how I did it. New position equals read. This is a cool library. It like handles everything for you. So, well, we'll see. We'll see about that. What is this function? What does the read function do? Well, let's find out. This is probably gonna spam it really hard, but I don't care at this point. I just want to see something, you know? And I could go to the documentation, but this is just more fun. So we're going to do encoder dot read. Oh, okay. Oh, wow. Okay, I don't... Okay. Let's just see what happens. No, it didn't like that. Encoder wasn't declared. What do you mean? Oh, encoder 1. Encoder 1. Sorry. So it's probably gonna spam a bunch of zeros. That's what I expect, at least. Yeah. Okay, and then what happens when I move it? Nothing. Interesting. New position doesn't equal the previous size and new position is... Huh. And I do the same here. It's like the exact same code. I give up. Let's read it. Let's see. I think this is the library. The documentation. I'm just wondering what read does, but fair enough. I guess we need to do that. Yeah. All right. And I followed the code pretty well, but it was the pin. I think what I did was fine, by the way, but I had the wrong pins. It's the second time I've done that today. So switch. Right. So it's 5 and 4. I think 5 is clock and 4 is DT, but I don't remember. Yep. 5 is clock. 4 is DT. 6 is the switch pin. Yep. All right. Hopefully we get something this time. And I don't see why we wouldn't. Oh my goodness. Okay, there we go. Yeah. Oh, okay, so read is just the current value, yeah. And notice how it goes up and down by 2. That's cool. Hence the code. Alright. Nice. So we're constantly reading that. Right, so the idea is, let's think. I don't really care about this number. All I care about is whether or not I spun it to the left or the right. And I wonder, yeah, see, this is also what this guy cares about. So we're gonna just, we don't have to rewrite this. And I don't want to, even though I am fully capable. We're gonna do this. So we have 4 variables. The position. Yeah. Okay, this is the previous position left, right? So this is what the position left was. Why left? Does he have two knobs? Oh, he has 2 knobs. Okay, he has 2 knobs. All right, so position, new position. All right, simple. This is what the position was. This is what the new position became, right? So new, I guess we are retyping it or rewriting it. New position equals encoder1.read if new position does not equal, I mean, let's just do previous position just so it's like easier to say. If new position does not equal previous position, so that means you spun it, okay? Oh, this isn't even keeping track of which way you spin it. This is, I guess we'll be able to figure that out. This is just printing it, and then it's set. Okay, that, which is fine. We can start with that. Okay. You read it. If the new position does not equal the previous, then print the new position, and then set the previous equal the new position. This is super simple. We probably need a closing bracket. This is very, very simple. We need 2 closing brackets. I think I deleted them. So now it's not going to spam print. It's just going to print once, hopefully. There you go. Now, I don't like this for multiple reasons, but one, if I twist it once, it goes twice. And that's because of how encoders work. There's like 2 switches in there, and each spin triggers each one. So, but regardless, it's really easy. So in my controller, which this is for, I don't care what the number is. All I care about is if you spin it right or left. Okay? So if new position is less than, what the frick? Is less than the previous position, I just want to print spun left. Spun counterclock. I'm just gonna do left. I don't, okay. Spun left. So, I mean, honestly, this is going to be like a menu, right? And it's, well, one example is navigating a menu. Another is just setting a value. Maybe you're trimming or maybe you're calibrating the servos. So you're spinning the dial to do that. I don't care what the dial reads as. I just want to know if it's spun left or right. So if it's less than, you spun left. Else if new position is greater than the previous, we do this. Okay. Spun right. And then print a new line. Now, I mean, these 2 lines are completely copied. So what we can do is take it outside of the if statement and neaten this up a little bit. You could argue that this isn't neater, but it's easier to read at least. I hate that. Okay. So if you spin it left, spin it right, spun right, print it, previous position equals new position. Cool. So like internally, yeah, it's keeping track of that number, but it's literally, it does not matter. Let's try it. You don't need to worry about switch debouncing? I don't know. Let's find out. I don't think so. Maybe. I mean, if it debounces the, what the frick? Worst case. Okay, maybe we did need this in the. Maybe we did need this in the statement because I forgot we were in a loop. Worst case, the menu gets a little like jumpy, but which isn't great. I think we do actually keep it in the loops, or keep it in the if statements. I mean, I could keep track of if it was changed and if it what, but it's fine. This is completely fine. I guess we can do print ln here to at least get rid of that line. Oh, we could do, okay. Here, if new position does not equal previous. There we go. Do this. And now this will be, oh my god, this will be on the outside. I mean, you could argue that this is the same amount of lines, but it's a little easier to understand, I think. And maybe you want to do other stuff with this. I don't know, but cool. So this should work. Let's see how well it works. Okay, this is interesting. So it's still triggering twice. And that makes sense. And yeah, you can see like this one trigger right here. That is what you're trying to demounce. I don't remember having an issue with that though, but I don't know. Okay, so what can we do about that? Maybe we only care about even numbers. I'm curious. I just want to see like what these numbers are. Also, it's reversed, by the way. The left is right and right is left, but it's fine. Yeah, so spinning it right is giving me negatives. Spinning it left is, yeah, but that's fine. So it goes like 9, 8, 7, 6, 5, 4, 3, 2. I mean, I could ignore... No, I can't really ignore odd numbers either. So how are we going to... I guess what you could do is like only trigger a spin right or spin left once it happens twice in a row. That would actually fix the debouncing too. In fact, I think that's why this worked. That would or not fix the debouncing. That would fix the, that would essentially be debouncing. Okay. Let's think about that. Spin right count equals 0. So if once it hits 2, yeah. Spin left count. Okay. This is right. Let's fix this right now. This is right and this is left. So it's just how it is. If this is true, spin right count gets 1. If this is true, Spin left count gets 1. I wonder, what if it was just the same count? Because then they'd like cancel each other out. No, I don't think that's a good idea. All right. After this, previous, that's fine. If spin right count is greater than or equal to 2. If spin right count is greater than or equal to 2, that is when it has officially spun to the right. Because remember, each spin triggers it twice. There's gonna be more. Else if, and then it's the same thing, but spin left count. Okay, but this isn't it though. This isn't it. If you spin to the right or spin to the left, we need to reset these counts. All of them. Now, this is some more repeated code, but it's fine. All right, let's see if this works. I feel like this should work, but we'll see. Yeah, interrupts are ideal. I just don't. I can't. I don't have enough pins. I don't have enough pins. Right. What? Are you sure? It prevents the same switch from being counted twice in a row. That's interesting. Does it really? I thought it just stopped your code and made it like instant. Oh, I don't know. Huh. Where did my... I swear to God I had this open. I must have backed out of it. No, yeah. You're probably right. Yeah. So... Oh, here. Where... There's probably... Yeah, here. Oh. Interesting. I mean, I don't know how to test this without doing serial prints, but... Well, whatever, let's see. That's interesting that it's like going crazy a little bit, but I could just add a cooldown on the button press. That's what yeah, that is what I'll do. Okay, something's not right. If new position is not equal previous, print the new position. I don't want that. Or maybe I do. I mean, that didn't seem to be skipping. That was weird. I don't have enough pins to use the interrupts. I would like to, though. Okay, so spinning it doesn't do anything. Let's try to debug this. What's previous position? So new position equals this. New
position does not equal previous. And if it's less than, oh, well, let's just start it at 0. I don't know. Why isn't this counting up? Typing's hard. Why isn't this counting up? Not sure. Okay. Oh. Spin right count plus. Is that not right? Is. Whatever. Okay. I thought you could do that, but you can't. I am sorry. Please forgive me. I still think it's not. I don't think it's working. 1, 1, 1, 1, 1. What the frig? Spin. Did I spell it wrong? Spin right count. Is it like it's printing? There's no way it's like going through all this. No, because it would have printed this. Why is it? Am I like being super dumb right now? Spin. It's printing 1, so it's either this or this. What is happening? Why can't I count a number up? I don't understand. It's like being reset somewhere. Hey, Rabbi, I am having trouble counting a number up. We're working on getting an encoder to work, and well, you can see it. Well, you can't see the encoder, but I have it off screen. The switch was easy enough, but for some reason this isn't working. If new position does not equal previous, this is printing, right? Let's just make sure. This is wild. What is happening right now? What is going on? It's working.
Okay, where is this value getting reset? In here, I guess, if it's greater or equal to 2. So no shit. Because it's never going to be 2. Oh my god. Okay, okay. So why isn't this printing? If this is actually triggering, wouldn't this be printing? But it's not. Are we ever getting here? Like, I don't know if does this work? Okay, I don't think we're ever reaching that point in the code. But, I mean, we do reach that point, right? Is this gonna... No, hold on, I have to re-update it. Okay, I clearly don't understand how breakpoints work in this IDE, but whatever. Spin right count. It's an int. It equals spin right count plus 1. And then I print it. Else do that, but we're never gonna get that position. Okay, look. Maybe something weird's going on, but I doubt this. This better not fit. This should not fix it. I don't. What's wrong with that? Oh. Wait. Oh my god. Oh my god. Oh my god. Wait. Are you freaking kidding me? I was missing a bracket? Wait, why did that not... What? I think I'm still missing a bracket. What is happening? Is that actually the reason? Because it was just it was always going to that code. But then why wasn't that printing? No, I don't. I'm not sure if that was the reason, but we'll see, I guess. Are you serious? That was actually the reason. Okay, I spin it once. It spins to the right. Yeah, this is working. One, two. Okay, it's Yeah, that doesn't fix. Well, it's not bad. It doesn't have to be perfect, especially since we're not using interrupts. But sorry, it's not going to be perfect, especially since we're not using interrupts. And it doesn't have to be perfect. It's just for navigating UI, so it should be fine. Is only closing the print statement. Yep, you're spot on. I hate C#, C++. I love C#. C++. Oh my god. But that was completely my fault. Like, it's fine. I don't. God damn it. Okay. All right. Got the encoder working. That's cool. So it definitely works. And it probably would work faster if we weren't doing all these print statements.
In fact, it would definitely be working faster. Let's try it. I mean, we can go back to this now, right? The actual code. And it should be faster. I don't know. It may be more accurate. I'm not sure. But, I mean, and it would be best if no printing. Ooh, that was weird. There were some rights in my lefts, but... yeah, I don't know. I guess, like, it's not perfect. Cause like those single, I'm not doing that. Those single rights in between the lefts. I wonder if I could fix that by like adding a cooldown on switching directions. I think that would work. So if the previous was spun right, you can't spin left for like a millisecond, because those random lefts within rights, for example, or vice versa, like that. This right, well, in this case. Well, in this case, the left shouldn't have happened, and it would have worked. Okay, I think that's what we do. And I think that's debouncing. Oh, the encoder library doesn't work well. Oh, boy. Yeah. Okay. I mean, no, I didn't think my stuff was wrong. So let's try that. Let's try that. I think. I'm just gonna be verbose. Is this an int? I guess it's an int. Time since last direction change. That's what this number represents, all right? So if you're spinning right, this is counting up. The moment you spin it left, or wait. Sorry. No, that's not right. Time since spun. That's it. That's what it is. I don't care if you spin it left or right. I just want the time in between spins. And if the time between the current spin is less than a millisecond or whatever, then you can only spin it the same way you have been spinning it. That's what I'm gonna do. Okay. So time since spun. Since spun, it would need to be a successful spin. So time yeah, time since spun equals, what is it, like time.get or something? How do you know, Ravi, do you know how to get the current time? Like the I mean, I can just look it up, but I'm wondering if you know it off the top of your head. Well, let's see if you can respond quicker than I can look it up. Get like clock or time? Yeah. Yeah, it's always, yeah, there's like a 30-second delay with YouTube, so. Oh, you're quick though. Yeah, that's right. I don't even know if I looked it up properly. I didn't. I forgot about that. It's millis, yeah. Right, milliseconds, there it is. Unsigned long. Can I just do long? Or does it have to be an unsigned long? I guess it could be unsigned long. All right. So, time since spun is set to this. If spin right count is greater than 2, the thing is, if the left spin gets triggered, but it shouldn't, I only want to delete the left spin count. I don't want to delete the right spin count. So what if I handle this somewhere else? Like, what if I never even counted the spin at all? I don't think I can do that. Oh, maybe. If new position does not equal previous. If new is less than previous. No, this won't work for multiple reasons. Okay, that's fine. Spin count is greater. If spin right count is greater than or equal to 2. Oh, cool. All right. We'll see. Yeah, there are 4. Yeah. And each position only has one possible transition for the next. There are 4 possible transitions, and each position only has one possible next transition for the next. Right. Okay, spin right, and you spin right again. Spin right, and then you're spinning left. Spin left again. Spin left, and then you spin right. Yes. Okay, I understand. But yeah, I don't need to make a state machine for that. Okay. I mean, I just need to keep track of the previous, whether you spun it right or left previously. Do I keep track of that? I mean, I kind of do with the new position plus previous. Oh, I guess spin. We can just do this. How do I make like a struct? I never know the syntax. It's like. I'm just gonna do a number. And previous spin equals 0. So this is fine. 1 is to the right, 2 is to the left. Okay, and we'll just default it to 1. If, here we go. If previous spin, so if you previously spun it to the right, if you previously spun it to the right, and then you're trying to spin it to the left, if you previously spin it to the right, and then you're trying to spin it to the left, if the spin count is greater than or equal to 2, and millis minus time since spun is greater than 100. Let's try that. We might go smaller though. Then you can spin it to the left. Otherwise, you can just spin it right to the right. No issues. If the previous spin was left, then it's that. Now I'm sure this can be optimized. I would hope this can be optimized, but I don't really care right now. Here goes nothing. And we could actually like keep track of whether there was an illegal spin or not. Cool. Wow. That was nice. There are literally no issues. Wow. All right. Let's see how well it's working. So if this, we're gonna do this. Thanks. No, Robbie, I don't need Discord call level help just yet, but I appreciate it. I am tired, but if I can't figure this out with a computer science degree, then we have some issues. We have some major issues. Although it is getting late. All right. Let's see. So I'm gonna break this up. So this is the same. This is good. This is what we want. And then if this fails, but inside the loop, we want to print debounce. Is debounce the solution or is debounce the issue? Debounced. All right. My guess is it's the solution, but I'm not entirely sure. Like you're debouncing something. Yeah. All right, same thing here. So we're just breaking it up into two if statements because we want the else statement to only be if this is true and this is false. I'm curious which way it debounced. All right, let's see if this works. Nope. Does that mean I missed a parenthesis somewhere else, or? Well, I guess we'll find out. Oh shit. Okay. Yeah, there you go. So this isn't necessarily debouncing. I'm just going really quick. I'm looking for like it to debounce like once, but yeah, actually that, yeah, there you go. Okay, so I'm pretty sure this was good because I definitely did not spin back to the left that quickly.
Interesting. Yeah, I mean, this is basically just adding a 100 millisecond delay between going right or left, which does fix it, I think. Yeah, there you go. There it is. I wasn't going to the right there at all. So now I'm going right. Yeah, I'm pretty happy with this. Cool. So with all these tests, I'm gonna save them in individual scripts, and then when I create the RC controller like actual code, I'm just gonna like mash it all together basically, and I hope it works. Although with Arduino and like how slow the loop runs, it might not. We'll see. So I also want to, now this might cause issues, run this logic through a shift register, which might not be a good idea, but we'll see. I need all the pins I can get, so we'll see. We'll see if this even works. I don't even know if this will work. For the shift register, I'm gonna start with just like basic buttons and then try to add the encoder on later. Although I'm gonna call it here. It's 1:30. I wanna go to bed soon. All right, Ravi, I'll see you later. Debounce is the solution, bounce is the issue. Got you. That makes sense. All right, guys. Yep, I'm gonna call it here. We made progress. We made forward progress, but my God, the NRF chip stuff, that was gross. That was actually gross. We got it working though. Thanks to Brick and Wagon for suggesting capacitors, which we were already using, but not correctly. And then for suggesting soldering the capacitor directly to the chip. This is the first time I ever got the antenna NRFs working, ever. So, granted, I haven't tried that much, but still, that's awesome. Try making a rule out of your last statement. I'm good, dude. I could optimize it. But I don't want to. So sorry. But hey, if you catch the stream where I'm writing the code for real, like the actual controller code, I probably will look to make something more optimized. But yeah, I hope you guys enjoyed this. It's live electronics, so it can either go well or horribly. Yeah, I'll see you guys later. I'll see you guys later. Oh my God. My brain is fried after trying to get that NRF thing. Oh God. All right. See you later, guys. Make sure, if you haven't joined the Discord yet, make sure to join that. The link is in the description of any of the YouTube videos. But yeah, have a good night.